Good morning. I would like to welcome everyone to this second stream for our Stardust Festival today. As you may have seen earlier, we are tuning in live from our launch site today and hoping to see some Launch Canada rockets from our great university students from across Canada. Ani Boju, Madison, Indigenous Cause, I would like to acknowledge that the lands that we are standing on today are Treaty 7 Anishinaabe Cree territories. We're really eager to be here today, and we have a great host of virtual speakers joining us today on both this stream and our other streams. Also, I would just like to remind everyone that if you have any comments, please be sure to use the Stardust Alliance or Stardust Technologies social media pages so we can get those comments to our great speakers. Miigwech. With that, I'd like to introduce our first speaker today. We have Sharif Alavi, who is an instrumentation engineer for the National Research Council, where he joined their flight research lab in 2007. Since his first microgravity flight in 2008, he's facilitated thousands of flight campaigns with national and international researchers from around the world. In this time, he has completed more than 11,000 parabolas on board the NRC Falcon 20. He is one of the co-founders of the annual Students for Exploration Space at Canada Reduced Gravity Experiment and Science Competition that I'm sure we have some students here today are eager to learn more about.
Thank you, Michael. This is Jin swapping
All right,
temporarily
with
from
that,
my
I will let you get.
Good morning. Can you hear me? Good morning.
Yeah, we can hear you.
All right.
Okay. I hear two people talking, but I'll continue. Let me know if you lose my voice. So yes, thank you for that introduction. Just slight correction. It's 1,100, not 11,000 parabolas. Still working on that. So as you mentioned, I'm an instrumentation engineer for the Flight Research Lab at the National Research Council. Before I explain a little of what the instrumentation engineer means, I just want to give a brief introduction on the National Research Council.
Society is evolving. Canadians are evolving. How will science keep pace with our changing needs? The National Research Council of Canada leverages research in science and technology to prepare us for the challenges of tomorrow. We collaborate with other innovators in Canada and around the world to advance knowledge and push
Sure, can't see the video.
Can you see the video?
environment.
No.
Diversified
No.
research leads to sustainable solutions.
Can you hear the
Watching
video?
the
I hear
stream,
it,
please
but we
excuse
can't
me
see it.
experiencing technical difficulties.
And help Canadian businesses bring
I'm gonna skip the video then. Sorry about that. You can see the slide again?
I just see the whole PowerPoint.
Okay, you can see the PowerPoint. Okay, so I'll just NRC is the government research arm, and we've been around for just over 100 years, and these are some of the highlights of our pedigree of what we've done in the past. So you can see
I'm sorry, sir. The slides are not actually changing. We just see the full PowerPoint screen. We're not seeing the changing.
Okay. What do you see? Do you see the PowerPoint screen
Now
now?
I see, yeah. But it's
Okay.
not there.
Wait. Now do you see the slide? Or do you still
That's
see
how
the...
you clicked it. I think you just have to do it.
Sorry?
Hello, can you hear me?
I can hear someone.
Yes. Can you just try and make it full screen?
Okay.
Hello,
You see these?
I can hear you. Can you hear me?
Yes, who's... Let me try, I'm going to stop sharing the screen and try to share again. Okay. Do you see that now?
Yeah, that's working now. Thanks.
Okay. Is this video working?
Society is evolving. Canadians are evolving. How will science keep pace with our changing needs? The National Research Council of Canada leverages research in science and technology to prepare us for the challenges of tomorrow. We collaborate with other innovators in Canada and around the world to advance knowledge and push the boundaries of science. We value the environment, and our diversified research leads to sustainable solutions. We connect with the most creative and innovative minds and help Canadian businesses bring cutting-edge products to market. We look ahead and address the critical issues facing Canadians. We are Canada's largest federal research and technology organization. Science for Canada. Science for you.
Okay, could you see that this time?
Yeah.
Okay, perfect. So yes, we're the federal government's research arm, and we've been around for just over 100 years. We celebrate the 100th anniversary about in 2016. So here's just some of the highlights, a very small selection of the highlights of some of the research that we've done over the years. You can see they redesigned a steam locomotive in the 1930s. Do you see my mouse if I move my mouse? Here. You can see radar and atomic energy were developed at NRC, pacemakers, wheelchairs. The red color for the Canadian flag was selected by the team here at NRC. In the 1980s, before CSA was around, the first Canadian astronauts were actually NRC employees. And in the 2000s, they we simulated brain surgery. 2010s, the first 100% biofuel test flights were performed actually on the same aircraft that we perform our microgravity flights. Well, NRC is located across the country from coast to coast. We're in Victoria, BC, all the way to St. John's, Newfoundland, and everywhere in between. Here's some of the locations across the country and the different types of science that's being done in these locations. Essentially, any science being done in Canada, NRC has some role in it. So whatever you're interested in, you can find some institute or research center working on that. These numbers are from June 2019, so they're a few years old, but we had about 2,100 scientists, engineers, and technicians, 179 buildings across 22 locations, 1.1 billion annual expenditure, and 1,500 research and development collaborations that have helped over 8,000 small and medium businesses. Currently, again, these are 2019 numbers, but they're probably quite similar still. It's women make up 25.3% of our STEM workforce. We have 426 students, postdoctoral fellowship and research associates, and our employees share 89 nationalities from around the world. So I'm part of the Flight Research Lab, which is part of the Aerospace Research Center at the NRC. We own and operate a fleet of fixed-wing and rotary-wing research aircraft, UAVs, and a broad number of aircraft sensors. We perform research for national and international industries, governments, and militaries. Our lab here is made up of 6 distinct groups which work together to get the research projects onto the aircraft and fly them safely. We have flight operations, which is pilots and flight test engineers who take care of all the actual flying, and we have an airworthiness committee, airworthiness department, which makes sure everything airworthiness and up to Transport Canada standards. Aircraft maintenance are all our aircraft maintenance engineers who make sure the aircraft do the regular maintenance and keep them airworthy. Avionics is part of the aircraft maintenance group. They're a subset of the aircraft maintenance who specialize in the avionics on board the aircraft. We have an in-house design and fabrications team. They do all the design for the custom research equipment, and we fabricate on site everything to install all the equipment, and all this is approved internally from the airworthiness department to allow it to fly. And instrumentation is my group. We take care of interfacing all the research equipment into the aircraft data systems. So one question I get asked often, especially from student visitors, is how did I get this job? So I'm going to share a bit of my background. Oh, actually, I'll get to the background. So I have a electrical engineering bachelor's from the University of Ottawa, and I did the co-op. And I highlight co-op here because I really feel co-op guided me in my career and got me to where I am today. My first co-op term was at the NRC Attosecond Science Group, working in a lab studying ultra fast lasers. So attosecond is 10 to the minus 18 seconds. So these were very fast laser pulses. I completed 2 terms there, and then I did another term at the Natural Resources Canada Material Testing Lab, also here in Ottawa. Again, it was they were testing a hydroforming press, and I did some of the instrumentation on that press. Following my graduation, I joined NRC full-time at the Chalk River Nuclear Labs in 2005. And then I transferred to the Flight Research Lab here in 2007, and I've been here ever since. So you might think, lasers, reactors, aircraft, what do they all have in common? How did I go from one place to the other? And the unifying thing is all these things need systems to control and data acquisition systems. So that's where I fit in. I'm part of the instrumentation group, where we design, build, and maintain the data acquisition systems on board the aircraft. So these systems interface both to the aircraft sensors and also additional sensors we add specifically for our research needs. We also integrate the client equipment into the aircraft. So if you have a research project, you want to come and fly some sensor with us, you'll be talking to our instrumentation group to see how we can power your system and record the data for your needs. We also, as part of the group, we operate some of the equipment on board, so we go on many of the flights. And this client interaction with integrating client test equipment and operating the equipment in flight is really what led me to microgravity. Now, before I continue, I just go back and just mention the fleet we have at our FRL. We have 3 helicopters. The Bell 412 and Bell 205 have been modified for fly-by-wire operation, which means they can be flown by computer rather than the original linkages from the control stick. We have the Twin Otter aircraft and the Convair 580, which are both remote sensing platforms. So we do a lot of environmental monitoring, Earth monitoring with these 2 aircraft. We have a T-33, which we use for high altitude measurements. It's been fitted with special pods that hold equipment, and it flies behind other aircraft to measure their emissions. Our most recent addition is the Cessna 337. This was a high test project case for a hybrid electric aircraft. So you can see in the picture there's 2 engines. There's one in the front and one at the back of the aircraft. We replaced the back engine with an electric motor, and the cabin is full of batteries. So this is one of the first electric aircraft in Canada. And finally, in the middle is the Falcon 20, which, as I mentioned, does some biofuel experiments and is the centerpiece of our microgravity program. So microgravity has a long history here at FRL. In 1986, the Space Station User Development Group at NRC requested that we develop the T-33 as a microgravity platform. So T-33 first flew a microgravity project flight in 1988. The payload capacity on the T-33, as you can see, it's a fighter trainer. essentially the back seat was the entire area you could fill with experiments. So that's about a few square feet of payload capacity. So in 1992, we moved the microgravity program to the Falcon 20. It has since been modified with hydraulic fuel and engine oil systems to allow it to do microgravity, and over time we've increased the number of parabolas we do. It's done thousands of parabolas in that time, and it's Canada's only microgravity facility. It's unique in North America. So what is microgravity, and how do you simulate it? Here you see a graph from one of our flights. The orange is the altitude we were flying at, and the red line is the acceleration experienced by the aircraft. So the pilots will fly we'll start at about 14,000 feet, and the pilots will pitch down to gain speed. At the bottom of this valley, they will, as the aircraft approaches its maximum speed, they will pull up sharply up to about 40 or 50 degrees. And at this point, all the kinetic energy at this valley we're trying to convert it to potential at the top. So as you're going up, this is when you feel 2G, or double your weight, for about 20 seconds. And as you go over the top, this period, all the kinetic energy has been converted to potential, and essentially we're in free fall as the aircraft follows this path. So for these 20 seconds, all the forces on the aircraft are equal, and you're essentially you feel weightless. And as you can see, the gravity goes down to it's very close to zero. It's about 0.01 G for, again, another 20 seconds. And then as the aircraft recovers, that potential energy is now being reconverted to kinetic energy. So we have another 2G portion as the aircraft recovers. And then we do it again. So hopefully you can see this video. This is a typical, this is a flight we had just last week. It's a very typical flight path of our microgravity flight. Is the video playing? So you can see we're in a certain area here. This is an area given to us by air traffic control. I'll just play it again. So once we enter the area, the aircraft will do there's 1, 2, and so on, series of parabolas. The spacing between parabolas depend on the clients we're flying on board and their experiment. Some need a certain time between parabolas to reset their experiments and get ready for the next one. Occasionally, when clients don't need any time, we can do multiple parabolas in a row. We can do 5 or 6 in a row before we have to turn around to stay in this area. So here's some videos of what it looks like during a parabola. These videos are all from different flights over many different years, so they won't be perfectly synced, but I hope they give you an idea of what we experience on the flight. On one side, we have the view outside the side window, obviously the cockpit window, and at the bottom we have a representation of the attitude of the plane. So this is the 2G portion when we're it feels like you're pointing straight up. And now the plane's starting to pitch over, and at this point it's zero gravity. You can see these little erasers floating around. Now the zero gravity is almost over. We've pitched from 40 up to 40 degrees down, and the pilots start the recovery at this point to return to level flight. that's what it looks like. People often ask me, what does it feel like? So here's a video of me in 2007, my first parabola on board the Falcon 20. And that smile you see on my face, that's the exact same smile I see on every first flyer's face, no matter what their age, what their background. It's quite a universal experience, but that sense of wonder in this environment that's really not recreatable anywhere else on the planet. Here's another video of me just playing around with some food. So that first video was my first parabola. This video is from a few years ago on my 1000th parabola. You'll see I have a little pipe here, a pipe T, and we're just doing a little experiment here. You can see, since it's off balance, as you rotate it, it's going to flip. So I'll play it once, maybe twice, so you can see how the instability of the pipe makes it rotate and flip in flight. And they're pointing up, pointing down. Here you see I'm not in my seat. The transition from 0G to 2G is quite quick. So we always have to make sure we are in a safe position before that transition comes, or you're going to fall pretty hard. I'll play it again. You can see it flip again. I'm rotating it. When I rotate it, okay, I don't think it's playing. So. No, okay, I'll move on. Well, as mentioned, I've had the opportunity to be a part of many different projects, coaching, starting from the project conception to actual implementation, and then the actual flights. I get to be a part of all that with the researchers. And one benefit of being on the support side is I get to be part of many different types of projects of different sciences, things that I had no idea about before I met these researchers. You can break down the types of projects we do into 3 different categories. There's fundamental research, which is just basically fundamental, basic physical principle, investigating basic physical principles. Applied research is a little more towards a goal of developing a product or some protocol in space. And then we have technology development and risk reduction projects where actual technology is tested. And for example, if you're sending something on the space station, you might want to test it on board our flight, make sure it works before you actually put it on a rocket and launch it to space. This is one of the first projects. This was actually the project that was on board on my first flight. It's with McGill. They were studying combustion of iron particles. So you can see they have a set of racks here with tubes. During the parabola, the tube is evacuated of air. A cloud of very fine iron particles are injected into the tube and ignited. And then the propagation of the flame is studied. And yes, we had actual flames on board our plane. So as I mentioned, we have our airworthiness department, and there was a very thorough safety review of all the equipment and the procedures to ensure that this would be a safe experiment for everyone on board and for the aircraft. I have a video of it here. It's quite fast, but you can see the ignition and you can see the flame traveling across the tube. This was all filmed with high-speed camera, so they have a really good idea of the motion of the particles. So we ran this project for a number of years here at, on the Falcon 20. Following those successful flights, it was repackaged into this. It was repackaged to fit onto a sounding rocket to be by ESA, and actually launched on a sounding rocket. Following the first launch, the new package was actually flown on board the Falcon 20 as well for some additional data, and it was subsequently launched on a second rocket. Another project we have with Concordia is studying the wheel swale interaction of rovers, specifically from Mars. So one thing I forgot to mention is in that parabola, if the pilots can not only simulate microgravity, we can also simulate other levels of gravity. Specifically, we tried to do lunar, which is 1/6, or Martian, which is 1/3. And this is done essentially by widening that parabola out. So it's the pitch up is not as the pitch up and pitch over in the parabola is not as sharp, and by alternating those rates, the pilots are able to simulate different levels of gravity. So this project was actually done in Martian gravity, as it's for a Martian rover. The researchers had this box, the sandbox, as we call it, full of an analog Martian soil. And then there was a wheel held on a bracket here, and it simulated rolling across the soil during a parabola. Again, you can see this is quite a big installation in the aircraft, so there was a lot of thought put into how to get this heavy equipment on board. It was also this, the sample regolith they were using is actually toxic to humans if it gets into your lungs. So we had to take a lot of precautions to make sure it didn't contaminate the aircraft, air handling systems, as well as harm the crew on board. So that's what this plastic you see is. It was a double layer of plastic to prevent any sand from escaping into the cabin of the aircraft. This was a project with a Polish company called SK Polska and the ESA. They were studying the effect of a net on a derelict satellite to see if they can capture a satellite with a net and bring it back from essentially deorbit it. So this was another complicated install in the aircraft. You can see the whole aircraft is white. This for better contrast with their high-speed cameras. There's 3 large lights, again for their cameras, and a 4th on the other side of the cabin. The satellite model is held in place in the middle of the cabin, and some compressed air is used to eject the net at the model. You can see here it's this is with their high-speed video, seeing all the motion of the weights on their net, and here's their simulation to see how it matches up with the real test. This was another test with University of Toronto with Professor George Zhu. I believe he also is speaking this week. This was a test for tethers of CubeSats. So you see we have a little model of a CubeSat in the middle, and it's held in place. It's held together with a thermal fuse. So when we press the button on the side, it burns the fuse and the two halves separate. So that was one of my colleagues was activating, and two of us were, I'm just off screen, they're just playing catcher. We've also tested inkjet printers for the space station with NASA. So the function we were testing with these printers was not so much the print head, it was actually the mechanism to feed paper. As you can imagine, in microgravity, the paper would have a tendency to float away if you would need a different mechanism to feed the paper. So HP, with a company named called Leidos, developed a better tray, and then we had a number of printers installed on the aircraft, and we put them through their paces during the parabolas. Project Possum, I believe there's some other, there's many people from Project Possum speaking this week. So Project Possum is one of the main things we were testing with them is this spacesuit for intravehicular activities developed by Final Frontier Design. So we've worked with them for a number of years now, testing this, giving different tasks to the participants in the spacesuit in the aircraft to see how efficient the suit, how effective the suit is in microgravity. So the first few campaigns we did, this was with the visor up. This was for safety reasons, in case the participant gets sick or feels unwell, they can quickly be they can access. Once they're in the visor, it's very hard to access them if the visor is down. So for the first few campaigns, we had the visor up, and then we finally, after we were comfortable with that in 2018, we did with the visor down. Of course, this requires a lot of monitoring on this system, so things such as temperatures and carbon dioxide levels. And then Project Possum is quite interesting because as we're doing this main spacesuit testing, all the participants are actually citizen scientists who have joined Possum, just like many of the people here today, just for their love of space and advancing the space technology. So each of them have their own experiments that they bring on board. So it's quite interesting seeing all these different people of different backgrounds with different ideas, all doing their experiments on the same plane at the same time. Here's a video of one of the spacesuit tests. This video is actually a 360 camera video, which has been flattened out, which explains the odd perspective. So this is participants, her feet are anchored to the floor, and she's going through some exercises to test the mobility of the spacesuit. And as I said, this is the cabin in a very weird perspective. But you can see on the floor here, there's a variety of different experiments. These are the other experiments I was talking about. So it's fluid experiments and all sorts of experiments that people of different backgrounds come up with. Most of them have cameras attached, so you can record the behavior in microgravity and analyze it after the fact. It was actually through Project Possum that the next my next project came about. One of the main drivers behind Project Possum is Dr. Aaron Persaud. And like myself, once he experienced the Falcon 20 microgravity, he really wanted to share it with everyone else. I try to show videos to people, I try to explain it, but it's really hard to explain the experience to people without them actually going through it. So Aaron approached me and we discussed starting a student microgravity competition. So he brought in the students for exploration of and development of space, and I brought in CSA. And in 2016 we launched the Canadian reduced gravity design competition. So we have a little video about it, and then I'll explain some of the thinking behind it.
The Canadian Reduced Gravity Experiment Design Challenge is a one-of-a-kind opportunity for students to design, build, and fly experiments in a zero-gravity environment. SETS Canada, in partnership with the National Research Council of Canada and the Canadian Space Agency, is bringing students the chance to put their skills and knowledge to use and solve real-life problems that will support Canada's future in space. To get involved, all you have to do is assemble a team and submit a design for an experiment that will further our understanding of a physical or life science topic in microgravity. The top 4 proposals will be given the opportunity to build their experiment and take it aboard the NRC's Falcon 20 parabolic aircraft in the summer of 2020. Don't wait. Proposals are due November 11, 2019. Become a mission specialist today by visiting www.sets.ca/CanRGX.
So this was
Hi,
really
Sharif. Just a quick update. We are running over time, so if we could just rush through the next couple slides.
Yeah, I just have 2
Thank you
slides.
so much.
Yeah, sorry. So yes, this was a project we brought together to get this an easy way for students to get on board the aircraft. So all the other experiments I showed had big installations that we had to go through all our safety reviews and ensure it was all safe for flight. So to avoid that, we decided to give an envelope for the students that is pre-approved, and as long as they're within this envelope, they can do whatever experiment they can think of. So we designed this case with CSA and NRC together. We designed this case to give them, which as long as their experiment fits inside, it's less than 45 kilos and use less than 600 watts, with a few other criteria, they can fly their experiment on board. So this was a way of simplifying the approval process and lowering the barrier of entry to the aircraft. This is just the timeline of what a typical campaign looks like. Essentially, in the fall semester, we ask for proposals. So if you make a team, you submit a proposal. We select 4 teams every year, and then the winter semester is spent with you designing your experiment, and we have a number of reviews with CSA and NRC, as well as regular meetings with SEDS to help you along your development. And then in the summer, we typically fly in the summer. We're just getting ready to fly this year's campaign at the end of August, and this year we're flying out of Calgary. This is the final slide. This is one of the projects I want to highlight from CanRGX. This from a number. The McMaster Merge team flew first in 2019, and they had their experiment set up. They were studying sloshing in fluids, and if they could put some screens to minimize the sloshing. So they had 3 tubes here, one with no screens and 2 different sloshing screen designs to see which one performed better. They flew this first, as I mentioned, 2019 with us. The results were so good, they actually came back and flew a second time in, I believe, 2021. And they just published a paper based on their results last month. So that's just an example that the projects we're doing are actually leading to real science. And that's it for me. Sorry, I went a little over. Have questions if there's any time for questions.
Hi, Sharif. Unfortunately, we are out of time for questions, but I really appreciate you sharing all of this with us, and thank you for taking the time out of your day to come on board the Stardust Festival and share this with everybody else.
Okay. So my email address is there. If anyone would like, feel free to email me.
Wonderful. Thank you so much, Arup. We hope to see you again next year.
Yeah, me too. Thank you.
Bye.
Bye.
All right. Our next speaker will be Professor George Zhu. Dr. George Zhu is currently a professor and Tier 1 York Research Chair in Space Technology at the Department of Mechanical Engineering at York University. He holds a number of titles and has also been the recipient of the 2021 W. Angus Medal of Canadian Society for Mechanical Engineering, as well as the 2019 Engineering Medal. Professor Zhu, please go right ahead. Thank you so much.
Okay, thank you for your kind introduction. So let me share my screen. Okay, can you see my screen?
Yes, we can.
Okay, yeah. So in this talk, I will share some of the research about space tether systems and their application in space exploration. So overall, first I will give you the some overall of space tether system, what the space tether system, and I will just provide some introduction of the types of space tether systems, and I will briefly mention past and current space tether missions, and then some of the research activities at my lab. So first, if you are not familiar with the space tethers, what is space tether system? So basically, space tethers are long cables, usually thin, and connected to a single or multiple satellites or spacecraft in space. Here are a few examples we will mention later. Like here we have the electrostatic tethers, and the application is we were used for the repair of the charged particle trapped in the Van Allen radiation belt. And here it's a kind of skyhook. It's the momentum exchange tethers. This is space tether, which is the first idea about the space tether system was first proposed by the Russian astronauts so here's a typo, it's 1885. And here we have dynamic tethered spacecraft formation. And also we have some space net. I think in the previous talk, Sharuk showed some of the tests about the space net. And then the tethered spacecraft or space hook for space degree capture and remove. Some partial space elevators. It is the subjective. We are currently working on it. And also the new concept of the electro-solar wind cell. I will mention it later. And that artificial gravity by tethers. So now let's talk about the space elevator first, because it is the first space tether system proposed in the history. So for the space elevator, it basically it says if we have a long tethers, one end anchored on the Earth, the other end connect to a spacecraft at the geostationary orbit. So then the tether system will be stationary relative to the Earth, and then you can access into the space by just climbing the tether. It sounds great, but there's an actual problem. First, if we look at the force balance in order to keep the up spacecraft in the geostationary orbit, and the force, right, the pull down gravity force should be balanced with the centrifugal force. And so that we come up with the geostationary orbit. But in reality, because the tether itself has the weight, so this and spacecraft must be moved up, so to generate some pull force on this part of the space tether. So then the this tether system can stay stationary in the space. So that's the basic concept of the space elevator. So it is great, but there is some challenges related to space elevator. It is a technical challenge, we will mention it, and also some of the material challenges. And for example, first let's looking at the material challenges. So if we assume we're using the strongest material available for example, the steel, and the density, about specific density is about 7.9, and we plug that one into the formula we have before, we can calculate the stress, maximum stress will be at here at the geostationary orbit. The maximum stress is 382 gigapascal, which is about 240 times higher than the strongest steel we can have. So basically, if you want to make such kind of space elevator, it's engineering impossible. We don't have such material. In the future, people are talking about the carbon nanotubes, which in the lab for a small, like a few millimeters, a few centimeters long carbon nanotube, it demonstrates the strength of the 1,000 gigapascal, which is sufficiently high than the maximum tensile stress. So in the future, if we can make a cable using the carbon nanotubes, it's possible we can make such a space elevator. However, as we mentioned, there's other challenge is as the cargoes climbing around the tether, there will be a Coriolis effect, which generate the force pushing sideways. So that will add that A, the stress problem more severe. B is we have to add more counterweight to counterbalance the side force. So as I mentioned here, right, it's a Coriolis effect. We have to little more. We have add more counterweight at the top. Okay, so to overcome this problem of the materials, we propose, or actually the professors in the McGill University, Arun Misra, they first proposed the partial space elevator or floating space elevator, which is instead of anchoring to the Earth's surface, we make a lower end floating in the air. So within that length, we can control the maximum stress in the tether by control its length. And in that way, we can make this space elevator concept is engineering feasible. So how to use it? So it's the basic concept is you launch the spacecraft with payload to the lower end of the satellite, and then you deliver the payload to this lower end, and then deliver the payload along the tether to the high orbit. That saves a lot of the fuels. as we mentioned here, the challenge for this one is, we did simulation here, because of the Coriolis effect, there's a side force pushing there. That makes the situation for the partial space elevator even worse because it's floating in air, and if they are not controlled properly, the space elevator will become tumbling. So one way to control or fight against this Coriolis effect is, as showing here, we have a multiple climbers to moving at predefined velocity profiles. In that way, they can work against this Coriolis effect using the gravity as a restoring force to keep this the space elevator in the vertical direction. The other one is the new concept we call the looped partial space elevator, which is proposed by my group. Is we say because the Coriolis force depends on how the directions of the climber. If you're moving up, your force going that way. If you're moving down, the force going that way. So we propose to have a looped partial space elevator. And then if we have a spacecraft moving down in this way and the other one moving up, then the Coriolis force, they cancel each other globally. In that way, we can keep this partial space elevator in the local direction, although each tether will be deformed a little bit. And also, because we're doing the loop transformation, and there's no limit on the velocity, and we can increase transportation efficiency. So this concept attracts a lot of interest in the community. So we receive some of the call from the Silicon Valley. They say, "Oh, yeah, is it engineering feasible?" We say yes, but needs a lot of money. So now it depends on who has the deep pocket, then we might be able to test this concept in the space. The next space tether system is the Skyhook. Basically, it's the a floating tether system like this, right? It's tumbling around there, so it will catch the spacecraft at the low end, and then you swing it and then release at the high orbit. So this is one way we call the momentum exchange. You can use the your small rocket, and it can deliver the spacecraft to the high orbit. So here is the concept that potential could challenge the SpaceX rocket. As I mentioned, you deliver your satellite at a low orbit, you catch it by the swing tether at one end, then you keep swinging at when it's reached at the high end, and you just released. The another types of space tether is we call electrostatic tether, and as this video shows, the charged particle in the solar wind will get trapped by the Earth's magnetic field in certain area above the Earth, and it forms a ring we call the Van Allen radiation ring. And why it is we need to concern about that, but now here shows why. Look at this is the Van Allen radiation belt or ring, and you look at our spacecraft. So this is the area where the International Space Station located. It's out of the radiation belt. It's okay, but you look at it, this is a GPS satellites, which is about 20 kilometers, and it's right inside this radiation belt, and also this communication satellite, which at the geostationary orbit, it's also within that radiation belt. So if that's why for the spacecraft design, the space particle charge is a big issue. So if we can develop some of the method to remove those trapped particles, that will be helpful to our spacecraft. So one way is you have a long tether, which is negatively charged, and then you flow that one within that radiation belt, and then that repel the particle charge out of this area. Okay, so the another application of the electrostatic tether is you can use it as a brake. We call the plasma brake for deorbiting a satellite or space debris in the LEO, because in the LEO it's not the real vacuum. There's a lot of plasma there. So if you have a charged particle, charged the tether, negatively charged, there will work against these electrons in the plasma, and then they will generate this electrostatic force against its motion. So basically add the drag to the satellite and accelerate its deorbiting process. Okay. Another type of a tether is we call the electrodynamic tether. Instead of using the charged tether, we use a tether which is conductive. So as it orbiting around the Earth's magnetic field, it cut the magnetic field line, and then because of the Lorentz, based on the Lorentz principle, the free charge in the conductive tether will be moving to end. Then the tether itself becomes like a biased. Then, okay, this is just a static, right? We cannot use it. So if we somehow put a electron emitters at the low end of the tether, then it will shoot the electrons, because it is biased by the magnetic effect, and then you can form. But if you shoot this electron back into the environment plasma, you will form a current within the tether, and like electric motors, and electrical current carrying tether moving in a magnetic field, it will generate a Lorentz force against its motion. So this is in the way that we call ED generator mode. It harvests the orbit energy. It's basically not the harvest, it convert orbit energy into electrical energy. So it can also either use this current as a power supply to the spacecraft at the cost of lower the orbit height, or you can use this force as electrical drag to deorbit the satellite. The other mode is we call the motor mode. So if we put a external electrical field by the power supply on the satellite to overcome the polarity of this naturally biased, so we can change the current direction in the tether by moving the electron guns on the top of the spacecraft. In that way, the Lorentz force is in line with orbital motion direction, so it actually can be used to boost the spacecraft orbit. So in my research, we mainly use this electrodynamic tether as the space debris removal. We call propellantless propulsion to move the spacecraft to lower the orbit of the spacecraft and do the deorbit. Okay. And then another application is the tethered spacecraft formation. So you know that a lot of people propose to use the small satellite to form formation to perform the task of a large, expensive satellite. The idea is good, but in order to keep the formation of the spacecraft, you have to use consume the fuels on the satellite. So once the fuels is gone, then the formation is failed. So to uh, to reduce the fuel consumption, you can use these tethers to tie those spacecraft together. In that way, uh, you can use a very small amount of fuels. Just keep this tether in tension to keep them in the formation. So another way is the artificial gravity field by tether. So in this application, you know that this I just show you the force balance at the lower and up spacecraft. You can see the gravity force is here, and they are different, right? The gravity force, but at each end, if they are not connected, then the gravity force has to be balanced by the centrifugal force. But if you connect those together, because those forces are now different, so then there generates some force imbalance at each spacecraft because they use the tether tension to tie them together. So that difference between the figure force and the tension is that generates the artificial gravity field. Okay. So there is other types of electrosolar wind cell. This is a pretty new concept. It was first proposed in 2004. So you probably heard about the solar wind cell. Solar wind cell harvest the energy of the protons in the solar wind. So electrosolar wind cell is different. They harvest the energy of the charged particle in the solar wind, and it can get more energy from the solar wind because those positive charged particle carries more energy than the protons, than the photons. So how to do it? So as it shows here, you have a very long tether, positive charge. The tether is about 10 to 40 kilometers long. In order to keep their stable, so you form them in like umbrella and rotate it to keep it stable. And then each line forms an electrostatic field around it. And then if you rotate it, it's basically form a plane which can repel these positive charged particle in the solar wind. So this technology can be used for a deep space exploration. And our group is now working on those engineering problems, like here to control it, right? First, it's how to deploy it. And you see the deploy the solar panel first to harvest the energy, and then deploy the tethers. And here you can see these auxiliary tethers, which basically to keep the spacing of the main tether to prevent the colliding of the main tether. Okay, so what's the engineering challenges of the tether system? So look at the slides here. For the tether system, you have the 100 or even 1,000 kilometers long tether. You cannot deploy in that way. So you have to store them in the satellite, and they tie them together into the space, and then they released. This is ideal situation. You release them in the local vertical. In reality, it is not. So here's the simulation we are showing how it will affect because of the Coriolis effect when they deployed. the tether actually lower satellite will swing. So if you don't control the deployment speed or the speed profile, the tether may swing over and then wrap the main satellite and cause a failure of the satellite. So our group works on this control of the satellite tether deployment use various kind of control laws. Okay, so here is some examples. There's a mechanical failure. So this is the video of the 1996 the space tether deployed by NASA. It's a 20 kilometers long tether from the space shuttle. So they tried the first in the 1993. The tether was jammed after 3 meters. Now, 3 years later, they deployed them again. The 20-kilometer tether was deployed, but at the end, it formed an arc between the tether and the space shuttle that cut this tether. Now this tether just floating in the space, and the satellite is also lost. After that, NASA just think the large scale of the tether mission is too risk, so they stopped to do that. But before they stop the large scale tether mission, this is the one. It's the same year. That's the 4-kilometer tether was successfully deployed, and this is the successfully deployed tether. And you have a two end. It's a two big satellite with the tether, and the tether was librate just swing about 50 degrees, 57 degrees as we predicted by simulation. And then the tether lasted about 4 years before it was covered. It was cut by the space debris. Okay, so then another type of the space tether system is the space net. Basically, it was proposed to capture the space debris or dead satellite and then use the space tug put into the lower orbit or then enter into the atmosphere to burn it away. Okay, this is the simulation, and here is the real mission performed by Surrey a couple years ago. I think it's 2017 or 2018. They did the test using the CubeSat. It shows the tether net. The space net was successfully deployed and successfully wrap these targets. Okay. Now I just want to show you the mission. So far, there's a 30 or 31 space missions. Tether mission has been done, start from 1967 up to the 2021. So far 30 mission was done, and half of them were not success. The tether were not successfully deployed. That include one of our own tether. We launched the tether, electrodynamic tether satellite in 2020, and that include the 100 meters tether, but it was failed to deploy. And the recent success was the TAPSI mission was done in late 2019. Was done by the U.S. Navy Research Lab. So they carried 1,000 meters of tether. The tether was partially deployed by only 400 meters was deployed, and because they overestimate the frictions within the tether systems. So the spring doesn't have enough energy to pull all the tether out. Okay, so here I want to show you some of the research in my lab before we wrap up my presentation. This is the test bed in our lab. It's you see there's an air bearing table. The air blow away from this little hose, and the table is rotational because we want to simulate the Coriolis force caused by the tether rotation, rotating around the Earth. And the table is tilted, so we can, within that 2 meters long table, we can actually scale up the result to few hundred kilometers tether in space. This is the one I think a colleague showed in the previous slide talk. So basically, this is the descent mission that the two satellites we launched in 2020, try to deploy those taped tether. The system works on Earth and but failed in the space. I don't know why, but we still try to figure out. And here is what we call the stabilization of space debris catched by the tether system. So we see there's a tug, there's a debris. It was spin, and we try to use a tether to pull it to de-spin the target. So this was done in a granite table, and we have two satellite simulators which carry the cold air, and it is air bearing and free floating on the table. So here it's the descent missions we have done. I just want to show you some of the work. So this project, I work with Ryerson University and supported by Canadian Space Agency. This is the team, and mostly this graduate students. And the concept is we deploy the electrodynamic tether, and we will try to tether the electrodynamic tether principle. So the satellite, the first one was ours, was injected into space from the International Space Station. That was done in November 5th, 2020. In the next year, in the March 2021, we issued the command to burn the tether. The command was exercised successfully. We received the feedback, but somehow the current was not sufficient to burn the tether. So the tie-down tether, so the satellite was not separated, and the tether was not deployed. So we hope we can try it again in the next mission. And here are the two slides showing the robotic stuff in our lab. This is some of the work. There's some of the work in our lab. It's we'll try to see if I can. Okay. Fortunately, it doesn't play. Okay, just try it. Oh, it plays. So you can see we have a robot armed on the one spacecraft satellite. It's free floating. The target spacecraft is also spinning, and it used the camera to look at the optical target here and align itself with the target spacecraft, and then capture the target autonomously. So this is the one we have the 6-degree freedom testing facility for the robotic capture of space debris and or dead satellite. Here you can see we have this robot to deliver the real spacecraft mission in the space, and then we have another robot grippers with the robotic camera here, and automatically guide the system to capture the space debris. So this is we use the force sensor here to do the active gravity compensation. So this we call hardware in the loop testing facility. So because this soft contact between the spacecraft is the most challenging. So here we try to repeat the real soft contact in the gravity free environment. Okay, that ends to my talk. Thank you very much. I'll be happy to answer questions if time allowed.
Thank you so much, Dr. Zhu. I've learned so much about space feathers. Unfortunately, we don't have time for questions and answers, but is there an email or something that people can contact you in case they do have any questions?
Yeah, no problem. I'll be happy to. You can send me the emails.
Wonderful. Thank you. I'll share that with everyone else
Yeah.
later on. Amazing. Thank you so much. And we really hope to see you back at Stardust Festival next year.
Okay. Thank you. Thank you for the opportunity. Goodbye.
Goodbye. All right. So our next speaker is Alexandra Armstrong. She holds a Bachelor of Applied Sciences in Mining Engineering and a Bachelor of Arts in History from Queen's University. She's originally from Huntsville, Ontario, but Alex has lived all over and worked in Melbourne, Australia for a period of time before joining Canada Nickel as the Community Relations Coordinator here in the North. Have taken on a variety of roles in her career, from operations and reclamation planning to drone piloting. Alex can speak to the wide range of unique opportunities that can arise from pursuing an education in STEAM. All right, let's bring you up, Alex.
Awesome. Thank you for that introduction. My internet is not awesome, so I'll probably leave my camera off. But do you just need me to share my screen for the presentation?
Yep, that's totally fine. And yes, please. I'll put that up on the screen for everyone else.
Thank you very much. So this presentation is a little more for people who are early on in their education or who are sort of in that deciding phase still of what you're hoping to do and sort of deciding where you plan on taking your career. I just wanted to share a little bit about my own experience, since my education is in both sort of traditional STEM, engineering, and also in the arts, just to give people a sense of what they can expect and sort of the lessons that I've learned along the way in my own journey. So my background, as we mentioned, I went to Queen's University. At Queen's, you get to do a general first year of engineering. I really had no intention originally of going into mining. I had very little experience in that industry. But in my first year, I just found the courses that had interested me, the direction I was looking to take my career, most closely aligned with a mining career. There was a lot of course variety. You get to take things from mechanical and chemical engineering to business to environmental sciences. And as you can see on the screen here, a few blasting courses as well. These are taken from during my third year in school. We had a blast site we would go out to. We mixed the explosives ourselves and then set them off. Mining supports a lot of travel, a lot of being in the outdoors, all things that I was looking for out of a career. I wasn't sure I wanted a set desk job, and I knew that this was the route that was going to take me out of that. And it's one of those industries that are ever changing and unique and very challenging. It's something that you have to evolve with industry and evolve with society to align with. It's also full of opportunities, but I mean, that can be said for really any education that you pursue in STEAM, is there's always really, really interesting, diverse, and unique opportunities. Because of this education, I had a lot of really amazing opportunities. I spent about 9 months in Australia, some of it studying through a course that was arranged by my university, and then another 4 months working as a consulting analyst at the university. I had the opportunity while I was there to travel all over Australia and do a 2-week backpacking trip in New Zealand. It was something that I don't think would have been available to me had I not pursued the education that I had and had my university not had this opportunity. A lot of my peers decided to do internships. Again, a really unique opportunity typically associated with an education in STEM is the ability to get really practical and real world experience while you're pursuing your education. I think that's something that a lot of people, it can be disheartening when you get into university and everything feels very theoretical. But a lot of the education streams that you can pursue through STEAM, like mining engineering, like space sciences, yes, there is theory, but you can really see the practical application to what you're studying, and it can make your degree feel a lot more purposeful. Again, because of this education, I got to take on some really neat jobs throughout my university career. I worked for a aggregates company as operations support and actually ended up being the drone operator for all of Ontario. I had never flown a drone before, but I guess I showed enough interest that they provided all of the training, all of my education,
Yeah,
and
you
then
didn't get
I
like
traveled
trained
around
Hi, Alex.
all of Ontario.
Sorry to interrupt. Quick question. Are you presenting the slides right now? Because we're still stuck on the winding path of your education career.
Sorry, you're not able to see the presentation?
We are. It's just still on the first slide.
Oh, okay. I'm
Yeah.
about 3 slides in.
Oh, so sorry. Yeah. Would you mind just correcting that and see if we could make that full screen?
I can certainly try.
Wonderful. Thank you so much. Okay, so while he's busy, I can show you the interface. So this is StreamYard.
Sorry, what was that?
Everything from here. And it's actually pretty easy. All right, welcome back, everyone. It seems like we did lose Alex, unfortunately, so we can move on to our next speaker. It'll be Glenn, Glenn Jaystadt, and Glenn has a background in folk pharmacology and has been performing agricultural research to address food security issues in remote northern communities. His research focuses on controlled environment agriculture and sustainability, and he strongly believes that agroecology may provide effective food security solutions for communities in harsh environments. This is the circumpolar Arctic and foreseeable future, off-world communities such as those that may one day exist on Mars. As the co-founder and president of the Mars Society of Canada, he has been working with a core team of volunteers who are committed to the development of educational programs, research and innovation projects, and analog studies for the benefit of Canada and everyone who is committed to developing a multi-planetary future for humanity through the exploration and inhabitation of Mars. On that note, Glenn, let's bring you on board.
Hello, it's okay. Am I coming through? Can you hear me? I haven't had a chance to test this mic yet.
Yes, you're coming through loud and clear.
Okay, perfect. Well, in that case, hello, Cochrane. It's great to be able to speak with you guys. I hear that apparently I'm going to be missing a rocket launch today, and I'm a little bit disappointed about that. But unfortunately, due to logistical difficulties, I'm going to have to do things virtually as far as introducing the Mars Society of Canada. So I'm going to. Hello.
Oh, nice. All good.
All good. Okay, I'm going to proceed then. It's
Sorry, you didn't use the full functionality of this.
Okay, can you see my screen?
Cool.
Not yet.
Okay, it's figuring things out here. Aha, there we go. And share, am I good?
You are go.
I am go for launch. Okay.
So right now, like.
Okay, so there we go. And well, it's great to almost be in Cochrane to talk about the activities of the Mars Society of Canada and where we're headed. I've been very impressed with what I've seen online about the Stardust Festival, and as a member of the Stardust Alliance, I'm going to try to make it to Cochrane this Saturday. Hopefully, I'll be able to get up there. The Stardust Festival seems to have taken a large cross-section of various students, academics, industry leaders, and space enthusiasts from the local community. Therefore, I'd like to begin to introduce the Mars Society of Canada by refining the focus and answering a really important question first, and that is, why specifically Mars? We could focus on activities in low Earth orbit, we could focus on the moon, we could even forego off-world aspirations and maybe focus on some of the more challenging parts of the Earth, such as Antarctica or maybe the ocean floors. Unfortunately, this slide doesn't really do justice to such an important topic, but in short, the challenge of Mars presents a unique opportunity for humanity to develop the kinds of ideas and innovations that will enable its eventual inhabitation, that at the same time will have direct applicability to what we do and how we choose to live on Earth. The most relevant kinds of innovations for both worlds might involve the development of more efficient water use and energy production systems. And something particularly close to my heart might be the imperative of developing highly efficient agricultural and waste management systems. It's a large part of my background. But if we choose to embrace the challenge of Mars, then by necessity we must also embrace sustainability. The long-term inhabitation of Mars will absolutely demand it, and the kinds of innovations and insights that are developed to enable this will have very direct applicability for Earth, most especially for communities in harsh environments that might be, say, suffering from severe food insecurity issues. Mars will be a powerful test bed for helping us to learn how to have a smaller ecological footprint, because that's going to be foundational to living on this and other worlds. Our motto is Ad Martem Pro Terra, which means for Mars, for the Earth, and we absolutely believe in that. So, a brief history of how we became the Mars Society of Canada. The Mars Society itself was established in the United States in 1998, and from there, various chapters were established throughout the world, including the Mars Society of Canada. Shortly thereafter, there were two fairly important events, which were the establishment of F-Mars, which is the Flashline Mars Arctic Research Station, which is a Mars analog station on Devon Island in Canada's high Arctic, and the third Mars Society convention that was held in Toronto in the year 2000. I happened to be at that convention, and between it and F-Mars, I was completely inspired and was determined that someday I'd also get to participate in an analog mission on behalf of the Mars Society. Unfortunately, I got distracted by graduate school and worked in Alaska for several years before I was able to return to that plan. MDRS, which is the Mars Desert Research Station, was established in Utah in the early 2000s, and it's been very well utilized, including by our very own Jin Sing Sia, who had a chance to participate in a mission there last year. The original Mars Society of Canada ceased their activities sometime in the early 2010s, and upon my return from Alaska, I was determined to reignite it and did so in 2016. Things really took off in 2018 as we became incorporated as a national not-for-profit, and we began to onboard a very enthusiastic team of volunteers. But of course, every team must have a mission. And please excuse the wordiness of the slide, but I wanted to answer the who, the what, the how, and the why. We are a volunteer and membership-based organization, and anyone can join. And if you're interested to volunteer, please get in touch with us. We are committed to developing educational programs, research and innovation projects, and analog studies, which I'll talk a little bit more about later. And we definitely abide by the principles of JEDI. That's justice, equity, diversity, and inclusion. And that guides how we conduct ourselves as we perform our activities. And I think I already talked a little bit about the why, but while conducting our activities, consideration will always be given to how they will ultimately enrich future Martian and terrestrial communities. And finally, some faces. This is a rough cross-section of volunteers who have been contributing to our activities over the course of the last couple of years. And one of the things that I've noticed about our team is their very high level of enthusiasm, and it's been great to be able to participate in many of the projects that they've either devised or have contributed to. We also have a board of directors who help to guide our strategies, and we're actually right in the middle of an election for 2 new directorships right now. We recently established a new local chapter, and there's going to be a little bit more to follow. And we're looking forward to growing our organization with the addition of more volunteers and members in the near future. So what have some of these activities been? Well, for example, with the assistance of Asa Kacha, Jin Sia, Evan Platt Weir, and other people, we've had the opportunity to develop some high quality content and begin to engage audiences with presentations. These have included presentations given at annual Mars Society conventions and a series of articles such as Jin's Diaries from Analog Mars that outlined his experiences as an analog astronaut at MDRS. In addition, we just recently hosted an online talk for our members featuring Tim Haltigan, who's a senior mission scientist at the Canadian Space Agency. We were very thankful that Tim took the time to do this, and I'm pretty sure that everybody had a really great time at that talk. Importantly, we're looking forward to hosting more speakers in the future. Our intention is to develop local chapters throughout Canada because it's one of the best opportunities that can be afforded or that can be offered to allow enthusiast students and professionals to network with one another and potentially engage the general public in their local areas. As such, I'm happy to announce the recent formation of a local chapter in Montreal. A more formal announcement will be following from MSC Montreal. However, it's based at Concordia University and is being led by Amanda Spilkin and Rim Chade, who are also members of Space Health Concordia. Their primary focus is going to be on education, mentorship, and the development of research projects, and they have a very strongly expressed interest in developing future Mars analog missions. We've also had the opportunity to develop a new educational program known as the Mars Explorer Program, which seeks to educate and inspire today's primary school children who are likely to be the Mars explorers of tomorrow. It's an online teaching resource that consists of fun, high-quality Mars-themed learning modules. Spearheaded by Hayden Hanna and supported by volunteers such as Zoe Lord at Concordia, they are presently seeking a pilot school that can conduct these first lessons. One of the first lessons will focus on the basics of growing plants in terrestrial soil and also in Mars soil simulant. The pilot teacher and 5 or 6 of their students will subsequently be invited to discuss their activities at the upcoming Space Exploration Conference, which is going to be held in Montreal in November. And speaking of this conference, we are happy to announce that we're collaborating with the European Space Agency on the Moving to Mars M2M workshop. Also, we're collaborating with Space Health Concordia on the Space Exploration Conference, also known as SPEX 2022, which will be held immediately after the workshop. Both events are going to be aimed at passionate students and professionals who are interested in learning more about emerging technologies and opportunities, both within Canada and beyond. Specific topics that we'll be focused on include aero-assisted vehicles, flight vehicle engineering, Mars entry, descent, and landing, rockets living and thriving in space, health, and smart habitats. And we hope to see you all there. In addition to hosting events, we also need to attend more events in order to grow, and I really, really wish that I could be up there. This is one of the best ways to let people know that we exist. As far as we've come over the course of the last couple of years, face-to-face meetings are still the best way to engage people, to grow our membership, and to increase the number of volunteers that we have available to develop and engage in projects. We've got a booth ready to go, and we are looking forward to being physically present on university campuses and elsewhere this fall. Ultimately, we want to be developing research projects and developing Mars analog missions. This is something which has been mentioned several times over the course of this presentation. This is something that first attracted me to the Mars Society of Canada, and something that's consistently asked about by our members and volunteers. Therefore, we're beginning to develop mission concepts for as soon as next year, possibly, that could be deployed at a number of different stations, including possibly FMars, maybe even at the future Stardust Space Center. Developing such missions is no easy task, and but we didn't get into this because we're afraid to embrace daunting challenges. If we can continue to grow and to engage with students, academics, industry professionals, funding agencies, and anyone else who shares the inspiration of Mars, I'm pretty sure that we've got a path forward, and we are determined to make that happen. And thank you very much for having me.
All right, wonderful. Thank you so much, Glenn.
Yeah, you're welcome.
If anybody has any questions in the chat, please drop them right now. But yeah, I guess Glenn, just out of curiosity, I'd love to hear a little bit more about like how you got started with this. What was the first spark that ignited your inspiration for this? I know you mentioned a couple of the Toronto conferences earlier, but I'm just really curious where your spark started.
Well, actually, it's to be entirely honest, I think that my interest in Mars actually goes back a very, very long way. It goes back to well before the year 2000. I remember standing up in front of my high school and actually giving a speech about the importance of Mars exploration. I think that was in 1990, so it goes back quite a long way. Since then, what has really ignited that spark and kept things going for me, I think, is my preoccupation with living in harsh environments. I mentioned that I was in Alaska, and what I was doing in Alaska actually was working as a research technician, working in a number of climate change-related projects, and had the opportunity to live and work in various communities from Siberia to the North Slope of Alaska to northern Canada to the very, very high Arctic. And I was always intrigued with the idea of how do you live in such a harsh environment. And when I came back from Canada, I was determined to do two things. First of all, set up some research projects having to do with agroecology, because one of the most important issues in these communities is how do you feed yourself. But it was also to set up the Mars Society of Canada with the intention of conducting research that relates to both areas, that relates to the areas of agroecology, how that can be applied in northern communities, and how it's going to be absolutely essential if we intend to inhabit Mars on any sort of long-term basis. So in short, I've always been inspired by Mars. I've always been inspired by harsh environments, and that's what keeps me going.
That is fantastic, wonderful. And again, just out of sheer curiosity, what's your take on Mars from the Expanse?
I, I have to admit that I have only seen, I believe, 2 or 3 episodes of The Expanse, and unfortunately, I've just been far too busy. But you know what? I really have to revisit my Netflix account because I was really impressed with those 3 episodes. And yeah, I think that I definitely want to become an Expanse junkie.
Lovely to hear that. All right. In that case, look forward to hearing from you when you do.
Okay.
All right. Again, thank you so much for hopping on and sharing more about this and about the Mars Society of Canada. I'm really looking forward to seeing you again, hopefully next year at the next Stardust Fest.
Yeah, I definitely intend to be there, and thank you very much for having me.
Cheers. Bye-bye.
Okay, cheers.
All right. Thank you for sticking around, everyone. We'll be taking a short break until about 1 p.m. We'll be back around 1 p.m. and yeah, we'll get going. We have a couple more interesting talks set up from 1 all the way up until 5 p.m. See you all then. Goodbye.
Hello, everyone. Welcome back. We've had a little break. Hope everyone's had a good lunch. Our next speaker will be
for like
Beth Munn.
10 minutes. Like, is your shit just gonna instantly?
She is an analog astronaut podcast host, narrative chief narrative officer as a professional space communicator. Beth helps people understand the connection between our advancements in space exploration and how they improve our lives on Earth. Beth is the Chief Narrative Officer at Stellar Communications, helping organizations discover, design, and deliver inspirational science-based narratives. She began her career at NASA as a public affairs officer for the International Space Station program. She's a visiting professor at International Space University, and she spent over a month in Poland in isolation study and lunar simulation, completing her second analog astronaut mission. Her first analog was a Mars simulation in 2021 at Hawaii's High Seas Research Center, where she had the privilege of serving on all-female crew, along with inspiration for astronaut Dr. C.M. Proctor. Beth had more than 20 years of speech writing and executive coaching for Fortune 50 companies, including Motorola, Allstate, and United Airlines. A keynote speaker, author, and often quite quoted industry expert, Beth invites space enthusiasts to become advocates by sharing the case studies, research, and lessons learned in the space industry. Beth served as a host and EMC of the 2020 SpaceCon Expo Global Space Commerce event, and in May 2020 helped to host the Humans to Mars Summit with Matt Kaplan. She currently serves on the Space Camp Alumni Board and a founding member of the Space Strength Association Board. Beth is the host and creator of the Casual Space podcast, sharing candid and insightful conversations each week with astronauts, engineers, and space industry leaders. Her latest project, Analog Missions, and podcast episodes can be found at bethmunn.com. That is quite the credentials list. Thank you so much. I will add you to the stream right now. Okay.
Hello. Can you hear me?
Yes, you're coming.
Oh, thank you, Umar. So good to see you, or at least hear you. And thank you for that kind introduction.
No worries.
That was really, I have got to shorten that bio.
Don't worry about it.
Well, thank you for having me. How's everything going at the festival?
Oh, it's great. We're out here at the launch site. The weather is beautiful, clear skies. We're just waiting for all the teams to get ready and start launching. So hopefully we'll see some rockets go up. It's really exciting.
That is so exciting. I can't wait to see that and hear all about it. So keep me posted. I can't wait.
You can follow. Oh, sorry. My mic quality is not great out here.
Well, good. Okay, fingers crossed for good weather, remain in good weather, and good flights.
Yes, thank you so much. If you want to pull up your screen there, I can pull it up onto the screen.
I'd love to share screen. All right, here we go. I think, let's see. Can you see it?
Not quite yet.
That's okay. It'll be there. I think in just a moment.
No, okay, I see it now.
You can see it?
Yeah.
There it is.
There we go.
Okay, so let me get to this beautiful, can you see this beautiful sunset type thing?
Yes.
Oh, good. Okay, we're good. Yay! I love it. Okay, so today, everyone.
You're good to go.
Thank you so much, Umar.
No worries.
All right, so here is something I've been waiting to introduce for quite some time, and it's just my honor to be able to do it for the first time with all of you right here at the festival. This is a project of love, and it's one that all of you, all of us can participate in. So let me introduce you, everyone, to the Stories Payload Project. This is something that came together from the Casual Space podcast and an opportunity that, because we're so good at sharing and enveloping our space stories, I'd like to share one with you to kick it off. I've had many guests on the podcast, and they're all just phenomenally impressive, most of which are in the space industry, obviously. But every now and then there's a guest that I really connect to. And I really feel like, there's a way in which we can share each other's story on another level. Well, that was the case with Stephanie Murphy, who is the CEO of Aegis Aerospace at NASA Johnson Space Center. So Stephanie and her company, Aegis, they are a small satellite payload delivery company, and they take payloads into space. And we talked about that on the podcast on one episode. And I said, we had a wonderful conversation about what it was like to be a female, to be a CEO, leader in this industry, in the space industry, and some of the challenges she's been working so hard to overcome and be successful in. And we just connected, had a wonderful conversation, and she made me an offer. She said, hey, Beth, if you ever want to fly anything into space, we're your company. And I thought, thanks, Stephanie, that's great. And what a kind offer. But I followed up. I called her out and I said, were you serious? After the podcast was over and we stayed connected, I said, did you really mean that? And the offer that you shared? And she was like, yes, absolutely. And I said, great, because I have a big idea. And that's how Casual Space Podcast Stories Payload Project became an idea into reality. So here it is. Later this year, this is what we want to do. We want to take people's stories, put them onto SD cards, and fly them into space. Your stories, my stories, everyone's stories. So how is this going to work? Well, the folks at Aegis have something called a MISSI. It's a payload. We love our acronyms. So this is a type of payload delivery system that helps orbital research and development testing. So I am going to gather all these stories. And on this payload, it says it consists of one payload with 3 objectives. We'll put into the MISSI science carrier. That's the satellite. It'll be launched to the International Space Station. And then the Canada arm will install it onto the MISSI flight payload, and it'll be exposed to space for 6 months. Now, this is scheduled for next summer, but as we all know, in the space industry, you have to plan quite a bit in advance to make that happen. So right now, from August, we're running this project and this payload and your story submissions until December. The project partners, as I mentioned, is NASA and Aegis Aerospace. And this might be the first time you've ever heard of Aegis, and I'm so very grateful to introduce them to you. You can hear more about the company on the episode of the podcast that features them, but we have a very small project team. It's myself and this wonderful student, everyone, named Katie Kemp, who's going to be going to MIT in the fall. And together, we named it the Stories Project, because that's exactly what we're doing. We're taking SD cards, testing them on board, and doing the research on the International Space Station while conducting this experiment and survey stories. So we want to accomplish 3 objectives. We want to actually test the SD cards. How do SD cards operate in space? Do they work well? Do they function? Radiation really damages space, equipment. It certainly damages us as humans. But sometimes electronic equipment is no different, and it gets damaged as well. So we want to look at that. We want to conduct STEAM and JEDI research, just equitable, diverse, and inclusive research via a survey that you take right before you submit your story. And those survey results will be shared later this year and all throughout next year as we gather them. And then, of course, to me, the most important part, most exciting part of this journey and this payload is taking the stories of space, especially women in STEM and in STEAM, and putting them into the payload, launching them into space. Okay, so let me break it down a little bit more. And I only have like 4 more slides, so sit tight, here we go. The SD cards, as you know, you probably have one in your computer or in your cameras or sometimes in your cell phones. They vary in shapes and size, but their function is to capture data, right? And store it. Some cards perform better than others when it comes to storing data. And when they get exposed to radiation, as we know, but we don't know enough, in space, these cards can sometimes have what they call bit flips. And what we want to test is take 100 cards and put them onto this payload. Open the payload to the harsh micro and gravity exposure of radiation in space, bring them back down after 6 months and see if they still work. See if those stories are still on those cards. Now, we'll be keeping a handful of cards back here on Earth to complete the survey and to complete the study to make sure that those stay undamaged. And we're going to work with NASA's testing facilities at the Johnson Space Center to really look at materials testing. Each SD card manufacturer uses similar, but sometimes different, very minuscule different materials. And this is going to be great because future people, future projects, future payloads need to have data storage, and they're going to need to be using certain kinds of cards. And we want to help test them so that in the future, commercial payloads know these are better, these are best, and these are, special, that work, have the best quality. And so we're looking into that now as part of this payload. Okay, now the survey I mentioned. The survey is on the website, which I cannot wait to unveil at the end of this. It's coming, 2 more slides. Those are just some of the examples of the questions, but they're not quite these exact questions. They've evolved as we started the project, and you'll get to see what these questions are. Now, why are we conducting research and asking these questions? Because we want to know who the storytellers are, because at the end of the day, we have an objective with this project, and that objective is this. This is the question that started it all. Can a story change the way we explore space? I believe it can. I believe it can, and I believe it can be yours. Your story can change the way that we explore space. So I want to know a little bit about you. Where are you coming from? What do you see yourself doing? What's your background here on Earth? So this is where that survey data gets collected. And later this year, when we're talking about this project in a big way at all the space conferences and on my podcast and at everything we're going to be participating in the future, I want to be able to share the answer, the yes answer. Yes, stories can change the way we explore space. And here are those stories, and here are the people. And it's very general data, but it's going to paint the picture of a human picture behind the stories. And that's what we want. So, and then finally, those stories, I believe, they're going to be powerful. And the website is so easy. It will guide you through submitting your story. It is just so great. Okay, so this is the project timeline. There's a lot going on. We're testing, we've already begun testing some SD cards. We've already launched the website, and we have officially this week, starting August 1st, started collecting the stories of space, your stories. And we're going to continue to do that until the end of the year in December of this year. Why? Oh, good question. Because we have to get the payload to the satellite carrier company, Aegeus, by December. Then Aegeus has to take that payload, deliver it to NASA so that they can test it and package it and tuck it nice and so safely into whatever rocket will be launching it. And at this point, it looks as if it will be launching on a SpaceX rocket in June. So there's a lot of moving parts to this, and everyone has to have their payload early. So, technically Aegeus and NASA are giving me a deadline till January of next year. I'm not doing that. We're not going to take that risk. The earlier they have a payload, the better. And I want them to have it in their hands so that there's just nicely ready to go, safe and ready to fly. Because I'm also a former NASA public affairs officer and station employee, I know that earlier is better. Nobody waits till the last minute at NASA. That's just not how it works. So I want to honor my colleagues and get them everything in advance. What does success look like for this project? And when I pitch sponsors and I want participants invited, this is doing this. This is the why. We want to, what is deal story storage for hardware in space for future commercial application. Like I mentioned, there's going to be future space commercial companies and users, potentially you and I in the future. And this is just a small component of what will be flying. Our data, or data from the photos we're taking in space, or data from the images we're taking from satellites and telescopes, and just needs to be stored somewhere. And we want an ideal storage opportunity. We want to show that women, especially, are very interested, very involved, and very participatory in STEM and in STEAM. Not just in this project, but in their idea of what a future space-going, spacefaring people can be. And they're as much and as part of the story as anyone. And of course, this is the first time a podcast has ever done anything like this. And I did neglect to mention, I can't believe I forgot, so excited, because I'm just so excited all over the board, that each story that flies in space will be selected once each week and read out loud and shared on the Casual Space Podcast. So after the project is long done and tucked away, those stories will be shared for everyone else on planet Earth to hear. How incredible. So that's what the story, and of course the partners. But now I'd like to quickly get into and introduce you to the website. Are you ready? Here we go. This, my friends, is the Stories of Space project. So you're going to put in your browser right now, do me a favor and be the first, because right now there's a few test ones, there's a few friends and family, but you can be some of the first official folks to share your story. You go to storiesofspace.com. And here you'll see 3 simple tabs. Here's what it's all about. Here is how you can help support this project. And here's how you can participate and submit your story. So, and you'll see this button all throughout the site. And I'm just about ready to walk you through how you can submit your story. So it tells you a little bit about who we are and what we're doing. Again, we're setting out to answer this question. We believe that your stories can change the way we explore space in really big ways. Your story will be launched from the satellite, as I mentioned, from Florida in Cape Canaveral in 2023, in June. It tells you a little bit more about this project and how rare it is for this opportunity. When I first approached NASA and Aegeus, I said, thank you so much for inviting me to send something to space, but just me sending something is not inclusive. It's just me and my family, and the only people that will ever know that I flew something would be me and my family and some friends I would brag to. That's not how I roll. I'm just such a staunch and fiercely passionate story conduit and story sharer. Why? Because your stories inspire me. They do every week on the podcast. So I just saw a natural connection and opportunity to say, why would I just send my story or my wedding photo or my ring or a piece of jewelry to space when I can give everyone the opportunity to do this, right? Of course. So these are the 3 easy steps that will walk you through. You have to register. You complete the survey, and it's literally, I'll show you the questions in just a moment, and then you follow along. This project will be successful and your story will fly if you can help me. Help share this, pass it along, hashtag it, put it into your social media, and let's just get this out there so everyone on Earth who wants to share their story in a big way gets to do it. Okay, and then of course you have to say yes to the legal disclaimer, because again, we're working with space companies and we're doing a big thing, putting a payload in space. So we have to make sure we do it accurately, appropriately. All right, and then I have some incredible partners. They're listed down here, but that's it. You can also sign up for the newsletter. There's more down at the bottom, but this is just a simple website because the only thing we need to do right here on this website is right here. So let's do it together. I'll walk you through quickly, then I'll take questions and open it up to your ideas and your suggestions or any other questions you might have. So that link throughout the site will take you here. This is where you submit your story. That will fly. As you can see, it takes 4 minutes. So you're just going to go ahead. What's your name? What's your first name? What's your last name? I'm just going to walk you through the questions because it takes this quickly. Your age, we just want to know generally. We don't use any of this data except to just understand where the stories are coming from. Your gender and where you're from. Are you currently in STEM or STEAM? Yes or no? Do you volunteer? We'd like to know that. How do you envision yourself in space in the future? That's a great question. I love asking kids these questions because they think bold, and the answers, yes, to thought-provoking, to innovative. That's a hugely loaded question right there. That's why I put it in there. Okay, this question comes from my analog astronaut colleague and mentor and friend directly from Dr. Cyan Proctor. When she heard about this program and this project that I was doing, she said, Beth, could you please do me one favor and insert a question for me? I'm like, yes, of course, Cyan. What do you want to know? And she's like, I want to know what Jedi space looks like to everyone else. She certainly has an idea, and she's on a mission to share Jedi space, and again, just equitable, diverse, and inclusive. But what does it look like for us? Does it look like someone who's blind gets to, travel and work and live in space? I think so, and this is exactly what we want to capture here. What does it look like in specifics? And I can't wait to read those responses too. Okay, we know space is hard. So what are some of the challenges that you are going to have to overcome perhaps when you live or work in space? Maybe it's financial. Maybe it's you have space sickness. Maybe you have a fear of heights. This can be really lighthearted. It can be a little bit more intense. But again, I look forward to the answers. And then how do you think a story will change the way we explore space? And then if you want to share your email, we reach out to you and we make sure that you know your story flew in space, and we keep you informed on the launch and the progress that we're making with the project. And then finally, you got to sign that legal disclaimer. You've got to, you have to. I can't move forward and take any stories that are vulgar or inappropriate. NASA will cancel the whole project if I turn in a story that's not, something that is appropriate to fly. So that's really what this legal disclaimer does. It just gives you the parameters about the story. So again, and nothing, violent, inappropriate, or horrible. So here it is. Here's the story. In 2,000 words or less, tell us what you're doing in space. A time we're working and living in space. And then I share a prompt to just kind of prime the pump and get you thinking about what your story could look like. So these are not required. You don't have to answer these questions in particular, in specifics, but they're just to help you kind of think about what when you share this story, what are you sharing? Is it an adventure you've been on? Are you at a particular place or location? Tell us all about it, and here's just some ideas. Folks, that is the Stories of Space project. It's your project. It's really yours. I'm going to stop sharing my screen. You've got the website now, and I've introduced the project to you. So I hope it's something that inspires you. I hope you take advantage of it right now, today, immediately. Put your story in. And if you want to think about your story and maybe write it or think about what you want to share and send to space, great. Go ahead, take your time. You have until December, of the end of December this year, December 31st. And the only thing I can't do is you can't copy paste your story. You have to type it out into that form on the website. That's how I can best take it and store it onto those SD cards that I'll be flying later. So let me answer any questions from anyone. Bring Umar back in if you want to chat with me a little bit about this project. Again, it's the first time I've unveiled it, and I wanted to do this strategically. Jason was so gracious and kind to invite me to do this here. I can't think of a more perfect place than at the Stardust Festival, where we are all sharing our stories of space and celebrating them in a really terrific way. So this is another way in which the stories, I'm getting goosebumps, by the way, because I haven't done this yet. It's the first. So I'm going to stop talking, or I'll just ramble about my excitement, and I'm going to let anyone jump in.
That was fantastic. Thank you so much for that. Yeah. Does anybody have any questions? In that case, I actually have a question myself. What's it like working with SpaceX behind the scenes?
So I haven't worked with SpaceX yet. I do have some contacts there, and they haven't been informed yet about this project, because it's really not up to me to be working with SpaceX. It's when you pay for a payload, which by the way, I'm paying for, and I need my sponsors to reimburse me and get this project flown, the satellite gets picked up by NASA, and they determine whose rocket it goes on. So as of right now, we were pretty sure it's going to be the SpaceX Falcon, but still yet to be determined. I don't see why that would change, but I'll be looking forward to, you bet I will be there at the launch. I will be working with them as much as I can. But right now, that's still the plan.
That sounds fantastic. Thank you so much. Yeah. So if there's no other questions, we're just going to take a 30-minute break until the next speaker. But thank you again, Beth, so much. Thank you.
Have fun, everyone. Good luck with those launches. I can't wait to see those photos and videos.
Absolutely. Hi everyone, welcome back to the stream. Our next speaker will be Dr. John Munoz from the University of Waterloo. He's interested in using human bodies specific technologies based on games and interactive systems. His research has been applied mainly in healthcare scenarios, from physical activity promotion for seniors to neurorehabilitation games for stroke patients. He has a BS in engineering physics and a master in bioelectricity from the Universidad Tecnológica de Peravia in Colombia, and his PhD in human-computer interactions at the NeuroRehab Lab, part of the Laboratory for Robotics and Engineering Systems in Portugal. He completed his postdoctoral fellowship at the System Design and Engineering Department at the University of Waterloo, and is currently working in the ITWIL and Social Intelligent Robotics Research Lab. He's currently a UX research scientist and product designer for JNF Alliance Group, creating adaptive biofeedback applications for mental well-being and de-escalation training in first responders using virtual and augmented reality. So without further ado, welcome onto the stage, Dr. John.
Hello, everyone. Thank you for the kind invite. Thank you all for being here. Let me share real quick my screen so you guys will be able to see some of the slides that I have prepared for you. So let me go briefly. Can you guys confirm if you can see what I'm saying?
Yes, we can see. Thank you so much.
Perfect. So thank you all for being here. The talk that I brought today is a little bit of a summary of some of the things I've been doing as researcher in the last decade. And I have entitled this Intelligent Virtual Reality Systems for Healthcare. My name is John. I work as a research scientist, and what a research scientist does is basically studying a subject in a very carefully and very creative way. We try to be as systematic as possible in order to provide scientific evidence of different hypotheses that we are constantly testing. I'm also a game designer. So what a game designer does is basically defining very fundamental elements of a game, like the game mechanics or the game technology, story, and aesthetics. So I found myself comfortable between these two different profiles, and I've been trying to combine the game designer mindset with the research scientist mindset in order to create some of the systems that I'm going to show you later today. I work in a specific field, which is called physiological computing. For the ones that are not very familiar with it, what we try to do is to connect different sensors to attach to the human body, and we are constantly recording the physiological responses. Those are the body responses, electrical responses, mechanical responses, chemical responses that we have every time that we are doing specific tasks. This is widely used for something that is called user research. So when you're designing an application, a game, when you are allowing users to interact with your prototypes, you want to collect those signals to better understand people's reactions, levels of stress, frustration, engagement. This is not a new technology. Actually, this has been used or widely used in the past, and it's called biofeedback, in which some clinicians were allowing participants to see their own signals in real time and providing some strategies for them to better control their signals. This is widely used in the clinical psychology field, and it's called biofeedback. So you somehow allow participants to visualize their own responses. The signals, the physiological signals, the body signals can also be used as input in a specific interactive application. So imagine something like this small controller is more like an airband. It measures your gestures, especially hand gestures, and it can translate those muscle activation into inputs for provide a more natural interaction inside games. Finally, a more interesting way of using this type of signals is creating creating intelligent adaptations. This is called biocybernetic adaptation, and it's basically an interesting way of creating artificial intelligence to allow the system to understand our body responses and react accordingly. So the system can adapt to stress levels, cognitive load levels, frustration levels in real time. As you can see, there's it's more like a transition between using these signals in a more passive way towards using the signals in a more active way. Interestingly enough, this concept was pioneered in the 90s by NASA scientists in NASA Langley. This is Hampton, Virginia. And the concept that they created is called biocybernetic loop. And again, is this idea of using the signals to close the loop, to create adaptation or intelligent adaptation based on the inferred human states. This has been promoted to be a very promising technology for fields such as healthcare, games and entertainment applications, and learning. Again, the main point here is for the system. Imagine you have a game system that is able to understand your physiological reactions and create adaptations in the game in real time based on those physiological responses. So I'm going to show you a couple of examples here of how I've been using this, especially in the field of games for health, which is the field that I normally study and do research for. This is back in Colombia. We created a dedicated rehabilitation room inside a rehabilitation unit where we invited people to come and play with some of the games that we created. So as you can see here, these are games that react to your movements and will allow the physical therapists and occupational therapists to complement their conventional therapies by allowing games, or interactive games in this case, to be used as a complementary activity for rehabilitation. You can see people with many different motor disabilities, people with stroke, children with cerebral palsy, and people having injuries, being able to conduct their rehabilitation process by using these games. We were using sensors, different gaming sensors, to quantify the movement. This game, for instance, uses brain waves, measuring attention and relaxation. And the main point here is to try to complement some of the therapies for children with ADHD and allow them to control or to modulate the game by using their levels of attention. So again, that was a way of encouraging participants to basically being able to conduct their therapies by using games. This initiative was awarded in one of the most innovative projects back in 2018 by the MIT Technology Review. The main point here was trying to use technologies like the brain-computer interface, low-cost brain-computer interface, and all the systems to facilitate or to complement the conventional rehabilitation process in centers like clinics or hospitals. The main point with this recognition was allowing researchers to have more visibility to the research that they were doing, and especially research that is conducted out of the lab. Part of this specific mechanism of creating applications that can leverage gaming technologies such as virtual reality, such as sensors that are capable of measuring body signals, is the use of these as a medium to provide a more engaging activities for people, for instance, in a stroke rehabilitation, to be able to enjoy more the sessions and be able to adhere more to the rehabilitation program that's being created for them. So we normally use many different neuroscientific principles to create this type of sessions. As you can see here, there's one that is called motor imagery, in where we ask participants, especially with stroke, to imagine the movement of their hands. Most of the times after a stroke, people have some struggle with moving upper or lower limbs, and it has been shown that through this imagining or through this imagery or recreation of the movement, people are able to reaccommodate some specific paths in the brain through a principle that is called neuroplasticity. And the main point with this is trying to facilitate the rehabilitation process. So what we did was basically using this paradigm called motor imagery, and now we connected that paradigm using a brain-computer interface and a virtual reality headset. So we show that through this multimodal virtual reality component combined with motor rehabilitation, we were able to provide a training that was more efficient than the conventional training. As you can see here, we connected this head-mounted display to participants. We used this brain-computer interface, and we recorded brain waves in the motor cortex. In this case, we're trying to see their intentions of movement. So first, we asked participants to actually move, so they will be able to more easily recall their move later in the rehabilitation session. Then we asked participants to repeat multiple times that specific movement, and we were providing feedback using hand gestures inside the virtual reality application. So you can see here we have a very accurate tracking of your hand movements in real time while the participant is in this virtual environment where you can open and close a gate. So for this specific case, we also asked participants, after a couple of repetitions with the actual movement, we ask participants to just imagine the movement. Every time there is a movement happening in the virtual environment, we ask participants to basically imagine the movement. So this is allowing us to collect the signals that will create the closed loop system, and at some point participants will be able to basically control the application in real time only by using their thoughts. So as you can see here, for instance, after the training, the system learns when a participant is imagining moving one of the hands and then is reacting accordingly. Again, the representation of the hands in the virtual environment and the possibility of moving their virtual hands in real time in a virtual environment is allowing the brain to rewire and regain some of those capabilities that have been lost because of the accidents, the vascular accident. So again, these are some of the applications that we have been doing in rehabilitation using virtual reality technologies, using gaming technologies, and using brain-computer interfaces as a way to access the brain activity and connect or interface that brain activity into that virtual scenario. If you have questions, feel free to just let me know. I see probably there's some people connected. I hope you guys are enjoying this specific topic. I know it's not a topic that we normally see or we normally see in many different presentations, but I think it's very applicable to many different fields. I'm going to show you a second example, and I will open this for questions in case you have. So this is a specific program that we are creating for conflict de-escalation in police officers. Again, we are allowing participants to go through virtual training, and we are interfacing that virtual training with physiological signals. In this case, we have heart rate levels and concentration levels measured with a wearable brain-computer interface. So I'm going to show you here the video of how we do this, but in a sense, we invite police officers to come and join into a series of virtual training using virtual reality. The police officer comes to our lab. We connect signals like this heart rate monitor and this brain-computer interface to record signals in real time. And then the police officers are joining to this virtual scenario, and they have an open range, and they can go through many different rounds. And depending on their levels of heart rate and the responses of the heart rate in real time and their attention levels, the difficulty of the simulator will change. So in this case, every time that the person is getting focused and concentrated using the weapon and also getting proper heart rate levels, then we will be able to change some variables in the simulator, like the amount of targets, or like if the targets are static or are moving, or also the velocity of the targets. So we created software tools to interface the virtual reality technologies with the wearable sensors, and this was basically a work that we did in company or in a company in Hampton, Virginia, that was licensing some of the patents written by a NASA scientist, Dr. Alan Powda. He's now retired, and what we tried to do there was using his biofeedback technology, so technology that can interface over body signals with gaming and virtual reality, and provide a scenario that could be used by this specific company to create a more user-centered, responsive, dynamic training using these wearable sensors. So I did this while I was doing my internship in the National Institute of Aerospace and a NASA team in Hampton, Virginia. And that's one of the things that I like doing the most, is visiting many different companies. This is, for instance, a company in Toronto that does this type of sensors that I'm normally using. And this is the game engine. It's called Unity, that I use also to create these virtual reality applications. So I also work, I have been working with Stardust as well in evangelizing, or more bringing this virtual reality technology to the youth, especially to teenagers and makers around the world, that will be able to use or recreate these scenarios using things like, standalone virtual reality headsets, or also using cardboard headsets that you can create at home. So I work a lot in the field of aging and rehabilitation. So if you have any specific question, feel free to reach out to me. And again, many thanks for inviting me to this talk. I'm open to questions now.
Wonderful. Thank you so much, Dr. John. If anybody in the audience has any questions, please feel free to drop them in the chat right now. But in the meantime, Dr. John, I'd love to hear a little bit more about, like, if you have any specific VR games, for example, that you enjoy personally yourself.
Yeah, there's a couple of them that I've been checking lately. Probably one of my favorites is called Super Hot. I'm sharing here some of the links in the game on Steam. The game, let me share the screen. The game is super interesting because it allows you to have this very low poly statics, and then the world moves every time you move, so you can have a control of the time. It's more like a Matrix-like experience. So this is called Super Hot. It's very, very interesting. And there is another one that is called I Expect You to Die, and it's based on the James Bond movie, and it's basically bringing you to this life as being a secret agent and a spy, and then you need to interact with many different objects and complete different missions while being in a virtual environment that is very interactive. I hope you can see some of the videos that I'm sharing here of the games that I'm recommending you.
Yeah, absolutely. Everybody can see that, and thank you so much for sharing about the games. And well, I'll personally definitely be checking them out myself. But again, thank you so much for coming on board and presenting and sharing some of your amazing work. If is there a preferred way that our audience would be able to get in touch with you?
Yeah, very easily. I will put here the link. It's basically my direct link to my personal website, and all the videos and all the different research that I have been doing using gaming technologies for healthcare.
Amazing. I'll be sharing that with the rest of the audience in a bit. And yeah, thank you so much for coming on. And we really hope to see you at the next Stardust Festival.
Sounds good, Umar. Thank you so much. Have a good one.
Wonderful. You too. Thanks so much. Bye bye.
Bye bye.
All right, everyone. It seems we'll be taking a quick, short 10-minute break until our next speaker comes on board. And once they do, we'll get right back into it. Thank you so much.
Hello, everyone. Welcome back. Um, Hello, everyone. Welcome back. I'm here with Dr. Jayshree. She is an associate professor in the Department of Electrical and Computer Engineering and faculty member with the Institute for Earth and Space Exploration at the University of Western Ontario. She got her PhD degree in electrical engineering from the University of Michigan Ann Arbor. Her research expertise is in developing novel nanophotonic sensors and miniature remote sensing instrumentation. She's got extensive experience on several collaborative projects with industry and academic partners. This research has resulted in 3 patents with practical applications in precision agriculture and geology. She's also involved in several CSA-funded projects related to remote optical instrumentation on lunar and Mars rovers. She's also the PI of CSA-funded Western University Nunavut Arctic College CubeSat project, UPIC-1, which will be launched from the International Space Station. She is also one of the founders of new space startup company Lightsail Limited. I will put her on right now. Thank you so much. Hi, can you hear me?
Yes. Can you hear me?
Yes, you're coming through loud and clear.
Right.
All right, so just pull up your presentation. I'll put it up on the screen.
Okay.
Okay, I have it right here. All right, you're good to go whenever you're ready. Thank you for being here with us.
Okay, just give me 1 minute.
Okay, sure, no worries.
Just moving around my screens.
Yes, no worries. I get it. Yeah, it's a beautiful day here at the launch site. We're just waiting for the teams to get ready, and we'll see someone go up very shortly, we think.
All right. All right. Okay.
Okay, good to go?
Yes.
Okay. All right, please go ahead.
So hello, everyone. I want to first thank Omar for the wonderful introduction, and I also want to thank Stardust Festival and Jason for the kind invitation to talk about what myself and then what I and my team of students do at Western. So I do hope all of you are enjoying the Stardust Festival and having a great time with family and friends. And what I'm going to talk about today is a little bit of background about myself, but then talk about mainly some of the work that we're doing, sort of an examples of work we're doing on building space instrument technology for remote sensing applications. This could be on Earth, and also for space exploration, including lunar rovers and satellite technology. So with that, let me move forward. So one of the things that I was asked is to give a little background on how I got into space. So I thought I'd just give a few slides, not to bore you too much. But I was interested in space since I was very young. I was very fortunate. I got a telescope when I was about 10 years old. And, using that, I used to go up on top of my apartment complex. And then, many nights I have looked at the sky. So it was almost an automatic interest in space and science. We used to get the Planetary Society magazine. Those were days before the internet, and National Geographic magazines all over the house. So, it's kind of obvious because my father was an engineer. My mother was a math, science, and computers teacher. So it's almost inevitable that I was interested in science and definitely in space. And then, of course, fast forward when it came time for me to go to university, I chose to become an engineer. And I got my degrees, as was mentioned, from the University of Michigan Ann Arbor, my bachelor's, master's, and PhD. And I was very interested in space and aerospace engineering and electrical engineering. And the reason I went into electrical engineering is because at the end of the day, what I'm really interested in when it comes to space technology is all the instrumentation. An electrical engineer is a wonderful thing to be if you want to work on those kinds of hands-on instrument technology. I did my PhD slightly different from space-related activities. I'm also interested very much in nanofabrication, in nanotechnology. So actually my PhD was in building a new kind of nano laser, to put it very simply. And so this is using this, we move forward. I wanted to point out a few things. Some of my experience, my initial experience in being involved with space and space technology came because of my exposure at the University of Michigan. So as I mentioned, I'm broadly interested in sensors and communications for these various applications. One of the first things, and this is something that you will find a lot of people who talk today, is one of the ways they get involved, is the University of Michigan has a Students for Exploration and Development of Space. And so I was one of the very first students to join a very new chapter of the SEDS long back, many years ago at the university. And one of the things we got to work on was something known as a Getaway Special Project. And as part of this project, we built a small experiment with microfluidics. And I worked as, not very surprising even from the early days, on the sensors and controls subsystem. And this was a small, you can think of it sort of barrel-sized experiment in a box that several universities could work on, and then they would fly it on this space shuttle. So a few years later, when I was moved on from that project, but still some of the work I'd done had gone into that project. This was flown in space shuttle. It had 2 flights for many reasons. One flew in January of 1998 with this experiment that a lot of the students at Michigan had worked on. And then the STS-88, we got a second chance to put that experiment on board. In fact, for those who might or may not remember the space shuttle, the STS-88 was the first one that actually went to the International Space Station. So as you can see, with this experience, was well on our way to being part of building instrumentation that will go into space. On Earth, so other things that I did, I did a summer internship with a company called Schlumberger. So this is oil and gas industry, but again, even there, what we were doing was really sending out instrument down the oil shafts and then oil and gas shafts, and looking for where you would find oil, where would you find other kinds of geology in the wireline testing. And then going forward, my senior project, I was interested in communications, and led a communication subsystems team for a Pluto flyby probe, which many years later NASA did send a Pluto flyby probe. So, and as I mentioned in my PhD, that was all during my undergraduate degree. And during my PhD, as I said, I really liked optics and light and imaging, and so this is what I do today, and continued from my PhD on to where we are today. So that's a little bit of background about me and my in the early days. So after I finished my degree, I joined at the University of Western Ontario as an assistant professor, and then moved on to associate professor. And what kind of research broadly we do here, these is just some examples that we have over here. So these are very nano components. So just to give you an idea for those who are looking there, this length scale over here is about 10 micrometers. So this is something you can't even see. These images are taken with something known as the scanning electron microscope. And so these are the kind of structures, as engineers, we design, then we develop it, and then we actually fabricate those very tiny sensors. So these are very tiny sensors. This is a part of my lab where we can test such sensors. And this is a field test where we test some cameras. So this is sensors, and the other part of the kind of work we do is to build different kinds of cameras. And I'll talk a little bit about that in some of the work related to space and remote sensing, because it's a special type of camera, which I will talk about next. And the other one I will, which is also exciting for one of the projects we're doing, is, as you heard, is that we are working, a huge group of students are working to launch Western University and Nunavut Arctic College's first CubeSat, UPIC 1. And so this is sort of a prototype image of that, of the CubeSat, right? And I want to say that one of the things, and as I think there are many members from the Institute for Earth and Space Exploration at the Stardust Festival in person, and this institute accelerates a lot of the work that we do in the lab, and actually, move it forward and help us towards missions and actually implementing some of this work so that for practical application. So it's very important, and I'm very proud to actually be part of the Institute for Earth and Space Exploration at Western University. And so a lot of the students, a lot of the training that the Institute does really prepares our students for, actually contributing in the space industry in the future. Right? I'm not going to go too in detail, just want to give you an idea. As I said before, I'm very interested in optical technology, also called photonics technologies, in remote sensing. And you will see that in everything you do, right? Over here, people use it for agriculture. And I'll show you an example of how we do that. We put it on drones. We can put lots of sensors on drones. You can put them on tractors. And these are all automated sensing of fields. We will talk about satellites. There are many satellites in orbit today. And they have many instruments, including many types of cameras. And this is very important because the data that they gather is very important for agriculture, to measure what's happening with climate change, and there are some energy aspects as well. And this is another example. We use LiDAR. We want to map what the LiDAR is, just a laser that's sent there, down to Earth. And when you get the reflectance back from the laser, you can tell how far an object is. And that gives us some idea of the terrain. So these are different things that we're doing. And of course, we will also look at space applications such as on the moon next. Before I go forward, I just want to say, because you'll hear this word a lot in the kind of work I do, it's called multispectral imaging. So first, let me explain what that is. Over here, you see what we call a regular image, the kind that you take with your smartphone or with just a regular camera. This is what's known as a red, green, blue image, or an RGB image. And it's just a single image which has all the colors in it. What we would like to do from a research perspective and to get more information is we want to take that image at different snapshots of color. So each color we would like an image. And then if you take it very finely spaced, like this, where the colors are very closely spaced, or what we call very close in the spectrum, you can get something known as a hyperspectral image. If you take 1 or 3, 4 colors, we call it a multispectral image. Why would we want to do something like this? We would like this kind of image cube because we get more information, and from that information we can gather things like what's the classification of what we're looking at, are the trees like this for here, are they diseased, are they healthy, and so on. Okay. So many things that we do with this type of camera. Over here you see that we have put this kind of a camera on the bottom of a drone. And this is actually an example of students who have taken it out to a farm, attached a camera that we have actually built here at Western, and then flown that over a field. And so this is sort of one type of image that we get, where it's actually a bunch of smaller images all stitched together. And this is actually the different images in the different color bands that we can then use for different applications. So this is different, as you can see, from the regular image that you would get. All right. So switching gears, so what has this got to do with space exploration? If you recall, the Mars exploration rover Perseverance was launched in 2020, and it has these two of these multispectral cameras. And this will be used for many things like geological classification, and they're attached on top of the rover, and they go around. They can tell you what kind of rocks and give you some idea of what kind of rocks are on the ground, more than just a single picture would, right? So this is a very important imaging tool that a lot of rovers will use, have used, and will use in the future. So what are we doing here at Western? As you may know, and you will hear, the Canadian Space Agency and are going to the moon, and lunar exploration can be done with unmanned and manned rovers. And as I was showing you in the previous slides, we want to build cameras that would image the moon. And with these multispectral cameras, what would we find with that kind of information? We want to find things like what kind of resources are there on the moon, right? A particular place of interest on the moon is the poles. We don't have a lot of information on what's happening on the poles. We have a lot of data from satellites and from previous missions, but there's still a lot that we do not know. So it's actually quite exciting. All these future missions are actually going to find out more. And some of the things they want to know is there water, ice on the moon? What kind of composition do those rocks have, and where are they located? So Western is involved in designing an instrumentation. It's called the multispectral camera for some of these potential future lunar rover missions. So one of the things I want to talk about, one of our interesting projects that we are doing here, in 2020, early 2020, Western was awarded a grant from the Canadian Space Agency as part of their Lunar Exploration Acceleration Program, or their LEAP program. And the idea was to design, build, and test a prototype that you can see over here of a integrated vision system. So this would have both a multispectral imager, which I talked about in the last few slides, and also another instrument, a LiDAR, which is being developed by MDA. And this was a project led by Dr. Osinski, who's a geologist, and my team here was instrumental in building this prototype of this very new instrument. And as I said, the purpose of it was for navigation investigation of the moon, and we were building very early prototypes. Now, this was a very new instrument compared to what we have seen before, because we were going to extend the range of colors that we could actually measure. So extend the spectral range to longer than 1700 nanometers. Okay. We were successful, and we actually demonstrated a prototype. The students actually took it to Mission Control's lunar yard and put these on a test rover bed, and you can see we actually took imaging of a analog lunar landscape over here. Another important thing, and for those of you who are interested in space, I mean, what this is allows is the student team got to go to do these field tests, do hands-on experience in both building the camera and testing it. You can see our students here at the lunar yard at the David Florida Labs doing some vibration testing on the unit. And also, I should mention that this photo that you see is actually taken by the camera and controlled actually from the handheld smartphone that the student has. So it's a very exciting project, and the students get to interact with several industry partners. So I think this is very exciting. So hopefully in the future, we continue to build on this, and you will see potentially a Western MSI on a future lunar rover, which is what we would like to see. And maybe you'll be part of that. We are doing other projects. I will go over this one very quickly just to give you an idea. Western is also involved in working with other companies like Honeywell Aerospace. We work with other universities, York, Carleton, University of Toronto, and we have a team of researchers. We work on another important aspect that's coming up today, which is you have many satellites in orbit around the Earth, and how do these satellites communicate? As we get more and more and we want faster communication, people want the satellites to talk to each other optically. And this is very challenging, because think about pointing a laser from one satellite and receiving it in another satellite, and doing this while the satellites are moving really fast. So this is another project that we are working on some of those components. We're working on a component known as the optical phase array, and different teams and different universities along with Honeywell Aerospace are working on the different systems. And the students get to design those very tiny nanofabrication type devices that you saw there. But this will be used for optical communication. All right, let me just finally talk about, I think, the exciting project from a student perspective. And this is our Western University Nunavut Arctic College CubeSat project called UKPIC-1. And this one, we're currently in the process of building the satellite and looking to launch it in winter of 2023. And this is the Canadian Space Agency funded Canadian CubeSat project, which involves 15 other teams. And we are one of those teams. And our payload is an amazing 360 VR camera that's an in-kind donation from Canadenses. So before I go any forward on what we're doing, let's talk a bit about, for those who don't know, what is a CubeSat, right? So first thing you have to understand, there's lots of different types of satellites that are up there in orbit. We have large satellites, medium, mini, micro, nano CubeSats. And I really like this image over here because it gives you an examples of those types of CubeSat. And typically the classification is based on what's the weight and volume of the CubeSat. And so what's considered nano is if the satellite is on the order of 1 to 10 kgs. And so a CubeSat is one type of nanosatellite that is around, around the 1 kg per unit weight. And I'll talk about just that. So CubeSat, which I showed you, is a very tiny satellite. It's also cube-shaped, and is usually one unit is a 10 by 10 by 10 centimeter cube. Think of it like a Rubik cube. And typically what people do is if they want to build a 2-unit CubeSat, which is what we're building, it's a 10 by 10 by 20 centimeter unit. So you can stack them up to, typically it's about 6 to 24 units, 6 being a very average number, 2 to 3 being what we do at the university level. And what's nice about this CubeSat is they can be built somewhat rapidly compared to relative space satellites. You can see many companies are launching them as swarms of CubeSats. They're simpler to design. A lot of the elements are off the shelf with a few elements that will be specifically made. And then they're relatively low cost. What this means is universities and other entities who are not necessarily in the space industry per se can actually build CubeSats and we can launch it. And that is actually one of our projects that we are talking about. So going back to what we're doing over here, so the Canadian Space Agency has funded this project. Our project is named UKPIC-1, and one of the reasons that it's called UKPIC-1 is our partner Nunavut Arctic College had a naming competition as part of their involvement in this project, and so what we as part of that naming competition, one of the winning name was UKPIC, and UKPIC here means snowy owl, and this is very apt for as you can see our payload, which is 2 cameras on the top and the bottom of our CubeSat over here. And so that will, so snowy owl is something with very big eyes. And so our satellite is giving us a 360-degree view of actually the Earth and the, since it's 360 of space and the Earth. And so this is our project that we are currently building, and we're excited to launch it soon. So this is, I think I'm running a bit out of time, so I'll just say that we have a large team of students. We have a project manager, Alexis Pascal, several graduate students who are a part of this. Some of them, I think the display unit is actually there at the Stardust Festival. So those of you who are interested, you can actually talk to Jin, who has it, and then take a look at it, Jin or Paul. And we have lots of undergraduate students over the years. Our outreach is supported by the Institute for Earth and Space Exploration, and our team doing the outreach is also at the festival. And we have several other COIs investigators as part of this team. All right. So as I mentioned, Nunavut Arctic College, we went there to visit in a very cold time of the year, February 2019. It was one of my very favorite trips, going up to the northern part, to Iqaluit, which is actually the southern part of Nunavut, which is several hours north from Ottawa. And next, what we will do, hopefully, of course, COVID did delay some of the things we want to do with them. But going forward, we'll be doing some operations of the CubeSat and more outreach with them. What other things are happening? The students get training through CSA run workshops, so they learn how to do space-related, soldering. You'd be surprised, simple things that are done on Earth, they have to be done very specially for a space environment. So students learn how to do this. This is an example of what the students were doing. Again, this is a large number of undergraduate students who did the first design, the initial designs of the CubeSat, and this is part of their learning final year projects. And students also get to go out, and this was one where the student team went to MDA in Ottawa to do some preliminary testing on the prototype, and then in that process learn how it's done in the industry. Okay. So with that, I just want to thank, there's a huge number of people doing some of the research I showed you, and on the CubeSat project, we have lots of industry partners here, and lots of collaboration with other universities as well, and many units within our university as well. And finally, I just want to end it there, let you know one of the exciting things we have going forward is we are potentially going to build a end-to-end space instrumentation facility at Western, which will have a CubeSat assembly room with an antenna ground station and a control and a data center. And so we're really looking forward to having future space missions and seeing one of our instruments or more than one of our instruments go up to space in a satellite or in a lunar or Mars rover. And if you have any further questions, I think lots of our team members are there, but I'm happy to answer anything in the time remaining. Thank you very much.
All right, thank you so much for a wonderful presentation. Unfortunately, we're actually a little bit short on time for questions. I hope you understand. We might be able to get one in if anyone wants to pop one in the chat or... Sorry, I'm actually being told that we are actually out of time for questions. I'm so sorry about that. Thank you for a wonderful presentation. Good luck with your research and good luck with your projects. Really hope you have a great day.
Okay, thank you very much.
Thanks for coming on. Yes, thank you. Hello? Hi, can you hear me? Hi. Yep. Hi. Oh, sorry. Let me just pop a quick introduction. So, hello, everyone. This is Ryan Stewart. Here's our next speaker from Johnson Space Center. He has an aeronautics and astronautics engineering degree from the University of Washington and has worked at NASA's JSC since 2008. The first 2 years were as a co-op for Mission Operations Facility, Engineering GNC, which is Guidance Navigation and Control, and Engineering Robotics. For 8 years, he's worked full-time in the flight operations of the ISS as an attitude determination and control officer, flight controller, and flight instructor. In this role, he supported over 2,200 hours of real-time execution support activities, from visiting vehicle dockings, undockings, reboosts, etc. He's also worked as an instructor teaching flight controllers, instructors, and astronauts about the ISS motion control system and soft skills required for the job. Currently, he serves as the deputy manager for COECI, working to increase the use of open innovation tools at NASA and increased utilization of crowdsourcing by NASA and much of the federal government. Thank you so much. Whenever you're ready to start your presentation, just pop it on and I will bring it onto the screen.
Awesome. Well, actually, my presentation is informal. I have no slides. You're going to look at me. Unless
that's awesome.
someone gets sick of me, I can always turn my camera off.
No, you are wonderful to look at. Don't worry.
Okay, I'll take that. I will take that.
Whenever you're ready, just
go
ahead.
I can, and just point for everyone that's listening, however many you are. I can't see you, so I can't know. But I really like this to be as much of a conversation. I would actually hoped to have been in person, but it didn't work out. Maybe if this happens in a future year, I can make that happen. But please feel free to shoot comments, put comments as you have throughout. I really want to talk about what you find most interesting. Now you know a little bit about my background. What I think's the best use of my time when I'm talking to folks who are younger in that they're not currently in the workforce is really some of the experiences that I went through getting to NASA, which can be equivalent to getting to wherever you want to be, and then kind of explaining some of the things that I've went through and some of the lessons I've learned as I look back, right? And so I have the benefit of having got to a pretty cool place, which is NASA, which I think a lot of the folks that are talking to you are probably have similar accolades, and that's great. You're getting to hear from all those folks. So real quick, my background growing up, I didn't know that I wanted to be an aerospace engineer, and frankly, I didn't need to be that. I kind of found myself in that route because I didn't know what I wanted to do, and I'm still been figuring that out. If you listened to my background there, knowing that I started as a flight controller, I was doing pretty different work when I was an intern, and then I went from flight controller and actually had a rotation in public affairs, and now I'm doing more of a business type innovation role. I've kind of been all over the place because I've been figuring out what is it that I really like, what is it that best for my skill set, what is it that I want to do. The great thing is I've got to do all those things at NASA, which is just an awesome place to work. And so it's been extremely exciting. But some of the things that I found have all resonated with me with a single method of moving forward, which was to take advantage of my opportunities. I'll give you some examples there. And again, if you're able to put in comments or questions, please do that throughout. I'd rather address what the direct things that you have, whether it's specific to what was my role as a flight controller instructor, what was my role, what's my current role, all of those things, or how did I get there? And so going back to what I was saying, take advantage of opportunities. So when I was at university, I was trying to figure out what I wanted to do, trying to figure out what type of engineering I wanted to do, because that's a path that I had kind of been following. My father was a pilot in the Air Force and eventually for Boeing. And so he worked with a lot of engineers and recognized that I had some skills that were similar to engineers. So I kind of found myself down that path, even though I felt like I was always pretty well-rounded, could do lots of things decently, but never one thing great, I would say. And so I kind of challenged myself and said, hey, rocket science is supposed to be hard. I think I could do that. Let me pursue this aerospace engineering route. And I found myself as a young sophomore in college at a job fair. And I almost didn't go to this job fair, but I did end up going. And at this job fair, I was looking for internships. And I was told primarily this job fair was for mostly juniors or even seniors at college looking for jobs, of course. But I was just, practicing, figuring, hey, I've never talked to companies before. This is probably something I should learn how to do. It forced me to make a resume, things I had never done before, even though that first one wasn't very good. And it forced me to put myself out there in a way I hadn't done before. And even if it turned out that I wasn't able to get any internships at this job fair, what the heck, right? So I decided last minute to go and kind of, with no preparation, went and talked to some companies. Turned out I only ended up talking to a few aerospace companies. But from that single job fair, I ended up in a really bad time for aerospace. In fact, this was 2007. I was able to get multiple internships. I got two, one with Lockheed Martin and one with NASA. And when I reflected back upon what was it that made it such that I was able to do that? Because there's a lot of people who were way smarter than me, way better engineers, better grades, more extracurriculars, better extracurriculars. What set me apart? And there were a few things that did that. One was that I'm pretty good at selling myself. I'm pretty good at figuring out what is the thing that I'm good at, or what are the things that I'm good at, and how do I relate that to what the person I'm talking to wants me to be good at, right? And so this is an important skill set that a lot of folks don't get. And I'm presuming that a lot of what you're hearing is about how to be an engineer or specific technical things, how to be a scientist, how to do specific technical things, which are important, right? If you're going to be in a technical field, you need to have that foundation, or at least be able to communicate with those folks. But being able to communicate about yourself is a really important skill set that a lot of people don't have. And I want you to all to recognize that as you move forward in life is a really, really important thing. Whether that's, you're the captain of your sports team, and that gives you leadership abilities, which then you can talk about how that sets you up for whatever you're trying to do. For me, when I was talking to the NASA HR human resources interviewer, it was telling that person that, hey, I went to space camp when I was a kid, or I used to live by Kennedy Space Center. I used to watch shuttle launches from my front yard. And I quickly recognized, based on the questions I was getting, that he was looking for someone who was a NASA guy. It was clear to me that NASA wanted to hire people who really liked NASA. And that was true about me to an extent, but probably not to the extent that everybody else was there. I just like a lot of things. But what I was able to do was show that person that I have these skills, that I'm someone who would be, interesting, or I'm someone who could be, fun to work with, all these things that are really important when you're hiring somebody. And so this is probably going drastically different direction than any of you would expect. But I want you all to know how important it is to really be able to sell yourself and really be able to understand what you're good at and communicate how that can benefit wherever you want to go. It's kind of a general, I'm standing on a podium, life lesson here. So I've still got no questions or anything yet, so I'm just going to keep going. So I found myself at Lockheed Martin. I did a couple internships there, which was pretty cool, being a part of a government contractor doing aerospace work. And then eventually at NASA. And while at NASA, it was just more of the same story. I've got to do a lot of really cool things, including being a flight controller for the International Space Station. So I can talk a little bit about that. And so hopefully you're familiar with the space stations, orbiting laboratory, about 250 miles up, traveling at 17,500 miles per hour. And so it's traveling at a rate that's basically impossible to comprehend, right? And that's all based on its altitude. And so the space station is that orbiting laboratory where the scientists on board, i.e. the astronauts, can do said science work. And so while they're up in orbit, then the astronauts really are doing the science that we can't do on the ground, taking advantage of the microgravity environment, taking advantage of the fact that we have radiation coming in all the time, everything that makes space unique, the temperature gradients, all of those things. And so while they're up in space, we have a flight control team, a lot of which are in Houston, which is where I'm at, taking care of their house, taking care of their laboratory so that they don't have to. It's really maximize the amount of time that they can spend doing said science work. And so I was one of those folks. As a flight controller, my position was ADCO, Attitude Determination and Control Officer, which meant that you could really think of that as the pilot of the space station. So we controlled the orientation. We're concerned with navigation. We have GPS sensors on board, but we also dealt with motion control. So we have large gyroscopes that are spinning, and we use angular momentum and torque to move the space station. But we also have Russian thrusters and then the Russian equivalents of all those sensors. And so really cool, really complicated things. But in that position, I was able to both fly the space station from mission control. I was able to, we were doing all the planning for that, leading missions, leading work. I was teaching flight controllers to do their job. I was teaching instructors to teach flight controllers, and I was teaching astronauts about how to fly, or sorry, how to be on the space station and deal with problems and understand problems related to the motion control system. And did that for quite a while. And it was honestly probably about as cool as it sounds. That's one of the great things about that job, is to be able to work in mission control. It's a very unique place. You learn a lot of really good skills, and a lot of skills that translate to life skills, like the ability to communicate efficiently, technical information in a really stressful environment was fantastic. But one thing that I found when I was there personally was it wasn't my passion. I didn't want to be there forever. And it was kind of scary, actually. That was my first real job. I'd been there for a while. I had done most of what I could. I got certified in all those different things, to sit on console as an operator, to sit on console as a specialist, to teach people about it, to teach instructors about it, to teach astronauts about it, to lead those missions, etc. And after a while, I never got to a point where I wasn't having fun, but I saw that in the future, and I was nervous that if I was there for a long time, that I wouldn't have fun anymore, that I wouldn't be enjoying it. And I always knew that it wasn't necessarily the only job for me, but it was such a unique experience that it was hard for me to leave. But I had one time while I was I was in a different country working on something with a coworker and explaining my situation, and I talked about how I was considering different options, but I was, scared of possibly making a bad decision if I went and did something else. Like, how do I know if the grass is greener, right? How do I know what's over there? And the funny thing was, is I never thought to myself that there are consequences to not making a decision. And he was the one that pointed out to me. He said, hey, but you should equally be scared that by missing things, by not doing something else, there's just as good a chance that you are not getting the good thing on the other side. And it was a whole new perspective for me that I had never had before. I got this far by, like I said, taking advantage of my opportunities, but I was scared to jump into something else, which is kind of contradictory. And so I found myself saying, okay, you know what? I can move forward here, and I can consider other things. And so, in fact, some of the things I was considering at the time didn't pan out, or they ended up not being a good fit, and I chose not to. And that's okay. But I think that this is an important thing to recognize, because whether you're working or whether you're in school or in a club or a sports team or whatever, sometimes you're going to be doing something for a while and you may want to keep doing it, and sometimes you may not want to. And only you'll know when it's right to make a change, but it's not inherently bad to make that change. But what you can do is, leverage the skills you've gained from what you've done thus far to your advantage. And so that's just, again, what I did. Just like when I talked about how I got to NASA in the first place, I leveraged the things that I had done prior and sold myself to the advantage of my next place. And so then moving on from there, I ended up doing a rotation of public affairs, like communications person, which is almost the opposite of the engineer background that I have and the technical operations work that I was doing. But they actually have a fair amount of, specifically at NASA Mission Control area, they have a fair amount of integration with the technical folks. And I was able to leverage that skill set that I had to be a unique player in their space. I was the first person who really understood the technical, and that meant a lot to them in a way that they didn't even know yet. And so I was able to help them, improve processes. I became like a tour guide at NASA who could speak to the technical work because I had done it all in a way that they couldn't do before. And so you'll see this theme of, like, as I moved through places, and it was as far from linear because I am not a good planner. I didn't know where I was going, and I'm still figuring that out. But as I've gone back and looked, I've gone all over places, but I keep leveraging what I've had before. And so, and it hasn't always been purposeful. I'm not going to take that much credit. It's just, I look back and I say, wow, like, this is what happened. And I hope others can recognize that this is a real thing. Like, there's real benefits to doing this. And so I went to that public affairs job, and while I was there, I was able to do a fair amount of stuff. It was a short time, and it ended up not being the place that I wanted to be forever for my own reasons. But I definitely got things out of it. I made good contacts. I was able to learn a lot about their processes and learn some new perspectives. But really, contacts are probably your biggest benefit. I mean, there's a lot of truth to who is important all the time in life, and knowing the right people can help you get ahead in any capacity. But so I left this after less than a year, and then ended up finding myself in my current role, where I now work for a team called COSI, which is NASA's Center of Excellence for Collaborative Innovation. And a lot of people probably consider NASA innovative, but also at the same time, when you think of government, or I can't speak for the Canadian government, but US government or any other government entity, there's a lot of bureaucracy, and thus innovation often is contradictory to what you expect with that bureaucracy. But NASA is doing a really good job in some spaces of innovation, including with the office that I have in COSI. And what we're actually doing is working with NASA folks and frankly other US federal agencies as well to bring problems to the public. And so we have like, hey, we need this widget, or hey, we need this software design or this graphic or whatever. And we are able to work with contractors to bring those problems to folks like you all. And in fact, we have, I'm going to post a link in the chat here if I can. Or maybe I can't. I'm going to put it in a private chat, and maybe Umar, hopefully I'm pronouncing your name, you can put that in for me in the chat that everybody could see in the comments. But if you go to nasa.gov/solve, you can see all of the different challenges and all the different problems that we bring to the public for which you can solve. It's really cool. We're able to get a lot of really good ideas from across the world, including Canada, and ingest those back into what we're doing at NASA. And you all can help us move forward, and depending on your age and the prize and all those things. I mean, sometimes you can win money or non-monetary prizes, but there's some pretty cool setups. But that's kind of all as an aside. But what got me to my current role, once again, was taking advantage of opportunity and leveraging the skills that I had in the past. And so when I moved back to my old job after that rotation, it kind of felt like I had moved back in with my parents, because all right, I had left and then come back to some role. So I had a feeling I wasn't going to stay there very long. And I was lucky to find a lateral move to this other position in COSI. And when I interviewed there, I pretty quickly recognized that a lot of the skills that they said were required for the job were things that I was a natural at, which I was happy. That's what I've been looking for this whole time. But I came from flight operations, and flight operations is known for getting work done, like just getting the job done, not complaining, being good under stressful work, good at multitasking. And those things, those skills really translate to almost anything. And so in addition to that, I had been in public affairs for a while, and certainly the group I'm with now, I was able to tell could leverage a lot of that knowledge and skill set, because they work with public affairs a good amount. And so, not on purpose, because honestly, this COSI team I'm on now was something I didn't even know about until I applied for this position. They needed these skills. And so you'll find that as I go around and pick up these nuggets of skills everywhere, I was increasing the my own portfolio, increasing how good I was at any possible thing, right? Becoming more diverse in my skill set, and then grabbing onto those little skills that were applicable to this new job and saying, look what I could do. Look how well I could do these things. And so fortunately, I was able to get that position where I'm currently at now, before eventually being promoted to a deputy manager there. And so, one second here. When I look back, it's this constant realization that, like, had I not done these things, had I been scared to move forward, had I not gone to that one job fair, which I was really, really close to not going to, my life would be so drastically different. Probably not terrible, but I certainly wouldn't have been at NASA. I wouldn't have had this great path that I've been on that I never saw coming, but it's one that I've been able to find by just consistently looking around and making sure that I was ready to talk about how I could be useful to said thing as soon as it came to me. And I just want to make sure that you all have that skill set when you're moving forward. I really wish I could engage with you in person so I could really tell if that means anything to you. All right. Do we have any questions so far, Umar? If not, I can keep going.
Hey, Ryan. Sorry, I actually had a question for you.
Sure.
I was actually wondering how differently do you find the work is between like technical communication and like what do you find is the difference between like your technical background and your colleagues who you work with who don't have that background? Could you just talk a little bit more about that? Thank you.
Certainly, yeah. So a couple of things. At NASA in general, you'll find folks of all backgrounds. Each center is like, there are about 10 main centers throughout the United States, and each center is almost like a little city. And so there's lawyers, scientists, engineers, cleaning people, management, business folks, creative writers, whatever. So you do work with a lot of folks, but you tend to work with little pockets that are generally about whatever your technical background is. Happens to be where I'm at now. Like you're saying, that it doesn't necessitate having a technical background, but I can tell you it is a huge benefit, because if you're able to match skill sets of being a good communicator with being someone who has the chops to communicate technically, that's pretty rare. There's not a lot of folks who can do that, and I found myself in that position currently, and it has really, really benefited me. And so I really, one of the things I do the most in my role is lean between government and non-government, and lean between technical and non-technical. And so I kind of have to be that jack of all trades, but to an extent. You can't know everything, and you don't need to know everything. But what I found is that I'm now in a position where I have to think about what is the person doing and what are they trying to say, and then convert that to what this other person needs and tries to say. And having a lot of different background and talking to a lot of people over the span of my life has enabled me to be able to do that quite well. And so I would say, for those who aren't sure if you should be in technical, but if you think you should, and you're not certain that your job needs to be technical, there is a lot of benefit still to having that technical degree, to having some technical experience, or wherever you're going to go with that. Because even in the space now where I'm not doing engineering work, day by day, being able to talk to those people about what they're doing in order to gain their trust, in order to help them implement solutions that they need, in order to help them through the business processes that they're scared of because that's not their world, is really, really important. And I've seen, I wish it wasn't this way, but I've seen complete shifts in sentiment regarding conversation when people find out, oh, you're an aerospace engineer. Oh, okay, good. Now I can really talk to you, versus we thought you were just some business person who didn't know whatever you were talking about. And nothing wrong with business folks, but of course everyone's biased. And so when I'm talking to engineers, I'm talking to scientists, they're biased towards the people who have the technical chops to keep up with them. And so I think I already said this already. I am far from a great engineer in any capacity. If you asked me to do some of the work that I had to do back at college, I wouldn't be able to do it right now. I'd have to relearn it. But a lot of school is learning how to learn. And so that I've got to the point where I can, I've seen something, I can have a discussion about it, and I can learn about it on the job, and then probably maintain that memory moving forward. Has really helped me get to that point where I'm able to communicate with non-technical folks. And then I guess the other thing is to recognize that I think it really goes with the STEAM theme of this whole festival, is that every part of a project has a lot of weight to it, and every part is important and is necessary. We see that all the time at NASA, where engaging the public is often just as important as some technical solution, right? Specific to NASA, we get our funding through government taxpayers. And so if they're not interested in what we're doing, their congressmen aren't going to be lobbying for NASA to get more money. And so it's important that people are excited. It's important that the world's excited, right? NASA was created to explore the universe for the benefit of humankind. And we can't do that if the humans aren't excited about us doing it, and if they're not informed about what we're doing. And you can't inform people without creative communication, which is really an art form, not necessarily just the technical things about it. And so I really found that personally, it's an important skill set to be able to communicate both ways. But I do want to reiterate to some people who might not realize yet how important the technical and non-technical work is when you're doing anything that's maybe considered stereotypical technical work.
Right. Thank you so much for that. And I think we've definitely seen a lot of that, especially with the latest James Webb launch, as you can see, which is our stream background right now.
Yep.
We've gotten so much excitement over the last little while over everything that's been coming out of that. And of course, the science and the data is great, but just seeing the universe is, of course, a huge component of it.
Yep.
Right. So I'm not sure if we have any other questions right now, but if anyone has any questions, feel free to post them in the chat.
That would just show up as a comment. Is that what that is?
Yeah. So under comments, I
Yeah.
think you can see on your end of the tab. Oh, you did actually post the link in the private tab. So
I'm not able to put it in the. I was hoping you could do it for me. I wasn't
Oh
able
yeah,
to
no worries.
put it in
I can do
public.
that right
I
now.
didn't have a login. I think that's the problem.
Ah, okay.
I don't see it. I only see Stardust and Stardust Alliance related comments.
Okay, I've just put it into all of our
Got it. Yeah, I see
active
that.
chats.
So yeah, that again for everyone is the link to public competitions that and public challenges that my organization puts out. And so if anyone's interested in being a solver in any capacity, you can look there.
Okay, we have about we're actually going to be taking a little break after. So do you mind if I just ask you a few more questions?
Please go ahead.
Yeah. Okay. Right. So I was actually wondering, how are you liking the like technical communication side of things versus the engineering side of things? If you were given a choice right now, would you choose to return to engineering, like to the more technical engineering side rather than the outreach side? And what would your reasons be for it?
Okay. So I am extremely happy where I'm at, and I would not leave it. My intern roles were like as more stereotypical engineering work, design, stress robotics, those kinds of things, guidance navigation control, coding for Orion, inertial measurement unit simulators, and all kinds of things like that. That was not me. I need to be around people. But again, this is me. This is like what I like. But if anything, it's maybe an interesting, journey that maybe some of you can relate to. Some people really dig that. I can do it, but it's not that I don't dig it. My role for 8 years was in operations, which is utilizing all of that technical knowledge, and you have to understand it, and then building upon it such that you can operate something. We were operating the space station, and then I was teaching about it. So you needed some level of technical ability. It's not quite the same, but you still needed a lot. Now where I'm at, I am really facilitating processes, facilitating business work. I'm managing people. I am integrating between roles, all those different things. And personally, I found that to be my sweet spot. I really like working with people. I really like communicating between technical and non-technical folks. And I found that to be something very personally pleasurable. But that's because those things align with my skills the best. So by being myself and doing things that I want to do, it's enabling NASA to be better, and it's helping NASA be better. And I don't have to work extremely hard to do that. And I feel appreciated. These are all things that I found to be really important, because I want to do good things and I want to work hard, but I don't want to have to work extremely hard just to catch up to somebody else. And so I've been fortunate that I've found different positions where I can try out different things. And personally, this position of being somebody with a technical background who can integrate information well, who can communicate information well, and can lead good operations and processes, those are things that I found that's like a perfect place for me. But to each their own. Every single person's going to have their own version of something like this. But I've talked to lots of folks, given lots of tours and speeches and things, and there's always a few people who are like, okay, good. I think I'm good at technical things, but I don't know if I want to do technical forever. And I want to make sure that those folks like me also know that there's a place for you somewhere.
Yeah, thank you so much. That's definitely one of the things that I'm personally interested in. So thank you so much for just having this conversation with me. Thank you for coming in. Really enjoyed your presentation. So we will be going on a break for a little while, and we'll have one last speaker in about an hour at 4:30. Thank you so much for coming out, and
Yep.
I hope you have a great day. We're hoping to see some launches very soon.
Excellent.
Yes, thank you. All right, have a great day.
Thanks. Bye.
Bye. Hello, everyone. We're so sorry for the delay. We had slight technical difficulties out here at the site where there's no internet and we're relying off of Starlink. All right, for our next speaker, we'll be introducing Brian Gallant. He is the CEO of Space Canada. He's a business executive and thought leader, and he was the 33rd Premier of New Brunswick. Brian was also the founding CEO and now expert panel member of the Canadian Centre for the Purpose of the Corporation. He also frequently provides business and political analysis as a media commentator. In addition to serving as Premier of New Brunswick, Brian was the Attorney General, the Minister responsible for innovation, and the Minister responsible for water quality. In 2018, he led his Premier colleagues as the Chair of the Council of the Federation. Prior to elected office, Brian practiced corporate commercial law. He has university degrees in business and law from the University of Moncton, as well as Masters of Laws from McGill University. He is the co-author of a major research report linking profit with purpose entitled Canadian Voices on the Role of Business in Society. Brian is supportive of many causes and initiatives as a member of several boards of directors, including the Asia Pacific Foundation of Canada, the Rogers Cybersecurity Catalyst, Canada Sports Hall of Fame, the Canadian Olympic Foundation, the Macau John Foundation, and the Beausejour Family Crisis Resource Center. I will now be putting him on the screen. Hello, Brian. Can you hear me?
I hear you loud and clear.
Okay, I hear you loud and clear as well. Thank you so much. So if you have a presentation, just pull it up and I will bring it up.
Excellent. So I'm good. I just wanted to chat today and hopefully be able to have a little bit of a dialogue if the technology will allow us to do so. I would really appreciate to hear any questions, any comments, any stories, any thoughts that you may have. I'll even accept compliments as well, by the way. So
you look wonderful today.
There you go. I dressed up, it's all good. So I'm really, really happy to have the chance to be here with all of you today. I'm so excited to be a part of this. I mean, I think it's a wonderful initiative. So a big thank you to the organizing committee, to everybody that's put this on. A big thank you to everybody that's attending and that's a part of this. It's amazing that you're taking time out of your days, your weeks, and your summer to be a part of this. And really, I'm just so honored and humbled to be invited and to have the chance to dialogue and discuss with all of you. Although it will be a little more one-sided since I'm virtually here in Ottawa and you're hopefully all gathered together, but certainly hope that through the virtual world we'll be able to do that. But before I get into sort of the topic that I'd like to talk to you a little bit about, which is sort of my story coupled with why I got into the space sector, why I joined the organization called Space Canada, and why I think all of you should think about education, careers, and experiences that are space related. So before I get into all of that, I want to start by taking a moment to reflect on the lands Canadians call home. I want to acknowledge the ancestral and unceded territory from coast to coast to coast of the Inuit, the Métis, and First Nations. With this acknowledgement, I recommit to take action to advance Indigenous reconciliation, which really must start with self-learning about the harms of the past, the challenges of the present, and the opportunities of the future. So on that note, what I'd like to talk to you about today, as I mentioned, was really a little bit of my story. If you'll indulge me for a little bit, if you'll bear with me, my story leads into very much as to why I then got into the space sector. And hopefully some of you, my story will resonate, or you'll see some things that you've gone through and that maybe you're going through, or maybe you'll even go through in what I went through and the reflections that I made along the way. So I, as was mentioned, was the Premier of New Brunswick at the age of 32 years old. So a lot of people say, wow, okay, you became Premier at a relatively young age, because usually we see people in those types of positions that are maybe a bit older. But I tell people that I decided at 15 years old that I wanted to be Premier. So it still took me 17 years to get there. So it puts into context, I think, my story and why I decided at such a young age that I was going to be Premier of the province that I lived in and that I called home. So the reason for it When I was 10 years old, my parents were working at Burger King and at a grocery store. They had worked at fast food restaurants, convenience stores, grocery stores their whole lives. And at this point, we were living in the southeast of New Brunswick. So for those who've already visited, it's called Moncton. For those who haven't visited, you all have to come. New Brunswick is beautiful. It's a wonderful place to visit. So hopefully at one point in the months or years to come, you'll come visit. And when you do, let me know and I'll let you know where to go visit. So when I was 10 years old, mother was working at the Burger King, my father at a grocery store, and my father lost his job. And it was really just because of the downturn of the economy, and he found himself looking for work. He ended up getting the same job that he lost a few years later, but that period in which he was looking for work and was having a tough time doing so was really tough on the family. And there are so many families, there are so many people across the country that go through worse than what we went through. And there are people that will go through worse as well. So I'm also very aware of that. But for me, what it does is it means that the terrible time that I had during those years and the family struggles that we had during those years, I put into perspective that it's even a lot worse than that. So it really gets my fire burning even more. So at the age of 10, when I saw this happening to my family, I decided I wanted to make a difference with my life. I wanted to help those that were struggling, people like my family that were maybe in a vulnerable situation economically, financially. So I decided at 10 years old, I had no idea how I would do it, but it was the fire that started burning when we went through that. So then I kind of stumbled into student politics. And I say stumble, I really did. Like one day somebody suggested I become the vice president of our student class group, whatever committee I think it was called in grade 5. And then I said, sure, why not? Nobody wanted the job, by the way. So probably the easiest election I ever went through. And then I just liked student politics and I stayed involved. And then I coalesced the feeling, the burning desire to want to make a difference with the idea that I really liked student politics. And the reason I liked it was because the job that I kind of had, that your responsibility was to try to make things a bit better for your classmates, for your colleagues, for your friends. It was to think about problems and try to find solutions. You get a chance to learn about a lot of stuff because you would be sort of thinking about how things work and how they could be better. So I just really liked student politics. And then I had this burning desire to make a difference. That coalesced at the age of 15. And I decided I'm going to be Premier of New Brunswick because I said, that's like student politics on steroids, right? It's like really enhanced student politics being the premier. And it will put me in a position to make a difference, to help families, to help those people that are struggling in the province that I love very much. So after I made that decision, every decision I made, I would ask myself, with the maturity I had at each step, don't get me wrong, but at the age of 15, the age of 17, the age of 20, 22, and it goes on. When I'd have a decision, I would ask myself, is this going to help me fulfill the purpose that I've chosen for myself? The purpose being to be Premier of New Brunswick, to make a difference for those that are struggling. So every decision that I made, I did the best I could with the knowledge and the experience I had at the moment to say to myself, would this help or will it not help? Maybe even hinder the purpose that I had chosen for myself. So I was so lucky. And by the way, not a lot of people do that. I acknowledge very much that I was an anomaly at the very young age to decide what I wanted it to do. And I often tell people, once we decide what we want, life becomes a bit easier. Our choices become a bit easier. Deciding what we want is hard, though. Deciding what we want to do, deciding our purpose, deciding what our burning desires are in terms of our impact, not easy. So I was lucky. And I made those decisions along the way. And I stayed involved in student politics. I joined debate teams. I studied at university. I started a small business to be able to pay for university, by the way, because I really had no chance to go based on the financial situation we were in unless I found a way. So I did that. And I started a second company when I was a little bit older, still in my studies. And that helped me pay for my university degree. So I went into business. I went into law. And that was because I said, if I want to run a province, I need to know budgets. I need to know finances. I need to know the economy. And then I need to know laws and how to make them and how to debate and how to discuss policy. So I studied based on what I thought would help me be able to fulfill the purpose that I chose for myself at the age of 15. So then an opportunity came around. I ran for the leadership of the Liberal Party of New Brunswick back home, and I ended up winning. It was not easy, don't get me wrong, and it was a lot of hard work in the moment. But one thing that I have to point out, which is pretty much the thesis of the first part of my story, is that because I had been working on it for so long, when the opportunity presented itself, I was ready. To say I was fully ready might be a bit too much. There was still lots to do, but I was ready enough to jump in and say, yes, I'm going to do this, because I had been preparing since I was 15. And sometimes I think in life, we all do this. I do this too in other realms of my life. We sort of want instant gratification, they call it, right? We want to put in an effort, and then the same day, if not the same hour, be able to see some type of reward or some type of impact right away. And that's hard if you really want to accomplish big things. If you really want to pursue a purpose, you have to be a little more patient, and you have to sort of tell yourself, today I didn't necessarily see something explicitly be an impact of the effort that I made, but that I know the efforts that I made today are going to help me in the medium term and in the long term to make a difference. So that's one piece of advice I think my story would sort of manifest. The other thing is, when I became the leader of the Liberal Party, I noticed that what I was drawn to were the things that helped me advance my purpose very directly. But what we have to be careful of is sometimes we have to do some work. We have to do some tasks. We have to learn about things that we don't necessarily love, that we don't necessarily enjoy. And I know it sounds weird, because a lot of people, and I'm such a proponent of following your passions and following your purpose, we often have people tell us to do that, but then they'll say, and then they'll give the impression, I should say, that you're going to be doing things that you love doing all the time because you're passionate about it. And I think it's the opposite. When you pursue something that you're passionate about, when you pursue something that is a purpose that's within you, you're actually going to be prepared to do the hard work. You're going to be prepared to do mundane tasks. You're going to be prepared to maybe work a little bit longer. You're going to be prepared to work on a weekend. You're going to be able to want to learn things that don't really interest you, but that you need to know to be able to pursue your passion or your purpose. So it's really fascinating. Passion becomes the fuel that makes you go through the tough times to be able to have the outcome, to be able to have the job, the career, the impact that you would like to have. So I hope you there's probably one thing I'd like you to remember from what I'm going to say today. It's that follow your purpose, find your purpose, then follow it, follow that passion. But don't think that following a passion means every single day and every task that you do is going to be a great day and it's going to be unicorns, sunshine, and rainbows, because it's actually the opposite. You'll find yourself doing tough stuff because you're really trying to push and make a difference. So then I became premier. I had the amazing opportunity to try to make a difference. What I did as premier is a whole other talk, but so I'll sort of skim over this, but I certainly will not skim over the fact that it was the most fulfilling thing I ever had the chance to do and probably ever will do. It was a job where I woke up every single day and I tried to make a difference. That was my job. It was try to make things better, try to have an impact like the way that I wanted to since I was 15 years old. So it was an amazing experience. So I'm going to gloss over that just because I want to talk about a few other things, but please don't think that I'm glossing over it because it was anything but the most incredible experience. It's just because I want to talk about a few other things. So then I left government and I left politics. And I had this really interesting moment. And I say interesting now, but I wouldn't have used that word back then because it was a very strange feeling for me. And the reason for it, I come to realize after a few months of reflection, was at the age of 36, I had fulfilled what I define as my purpose. At 15, I said I was going to become premier to try to make a difference for those that are struggling. And I had the chance to do that. And I accomplished that feat as I defined it. But then what I realized, I made a mistake when I was 15 years old. It's a nuance. It's not going to sound like a mistake when I explain it, but it's a mistake. And I'll explain what I mean. when I was 15, I decided I was going to be premier and make a difference. So I took two things and I put them together. Those two things shouldn't have been together at the age of 15. I made that mistake. I coupled these two things together. So I coupled the idea of the impact that I wanted to have with my life, the passion that I had to make a difference, defined here, and then I chose a position and I put those two things together. So I shouldn't have done that. I should have had my impact, the difference I wanted to make, as the ultimate North Star that I would be using for my life. And then becoming premier would be one way in which I could do that. But I actually coupled these two things together. So when I came out of government, I was lost. I didn't know what I should be doing next. I had no other plans. My whole adult life, for decades, was me thinking about the fact that I wanted to be premier of New Brunswick. So it was so weird. And it took me a few months to realize that I made that mistake. So when I realized that, and that's why I want to pass this on to others, because I don't want them to make the same mistake. When I realized that, I decoupled these two things. And I said, the position was a vehicle to be able to make that difference. What I really want is the impact that I described when I was 15. So check mark, I did that position, but this remains. So then, as soon as I realized that, I was able to start to look for opportunities that would help me continue to have an impact. I'll probably be the first to admit that being the premier is probably one of the best ways to have an impact. I mean, there are a few other professions in the country that would probably be able to have a little bit more of an impact, but it was such an incredible opportunity. But nevertheless, I was going to look for more chances, more ways in which I could try to advance the impact, the difference that I wanted to see in the world when I was 15 years old. So once I decided that, I took on a bunch of different opportunities. I wanted to try things out. I was like, wow, this is so amazing, right? I mean, I was super happy that I became premier. Don't get me wrong. But my whole adult life, I just thought of that. I never even thought of any other positions, any other types of responsibilities or opportunities. So I went and I took on 3-4 things. I wrote a report, which was mentioned in the intro, which I really loved doing. It was super fascinating, met really cool people, thought about things differently, from climate change to inequalities, to inequities, to Indigenous reconciliation, to Canada's place in the world. I was hearing from these thought leaders and business leaders on these important topics. I joined a communications firm to learn how to better communicate with the public, to better communicate with key stakeholders. I joined a university to be able to sort of be immersed in innovation and all these startups and incredible individuals doing such wonderful things. And I was really enjoying myself. Then I got approached to apply for a new job, and it was in the space sector, leading an organization called Space Canada. So what Space Canada does, on a side note, for those wondering, it's an organization that represents the Canadian space sector here in Canada and represents the sector abroad, so internationally as well. And we also work with the ecosystem, the space sector ecosystem, and key stakeholders to advance the space sector here in the country. So that's what our organization is responsible for and what we do every single day. So I was approached to apply for this job, and I said, wow, like space, just the word space sounds cool. I was interested. I wanted to know more. So I started to look into what the organization would do, but then I just looked into what was happening with space and what are sort of the challenges and the opportunities and the discussions. And I just became completely fascinated with the impact that space has on our everyday lives, the impact space can have on the societal and planetary challenges that concern me, and I would argue concern all Canadians, or at least most Canadians, what space can do to improve our quality of life here in Canada, but across the globe, and just what it can do to help us understand who we are, where we come from, and really just a better understanding of our place in the universe. So I was absolutely over the moon, pardon the pun, there's lots of puns in the space sector, to be approached to apply. So I applied and ultimately ended up being offered, and I ultimately accepted the job. So I'm just super excited to be here with all of you today, because with that job, with Space Canada, we have lots of things we're working on, but one of them is trying to encourage Canadians and try to encourage youth to get involved in the space sector, to get involved in space-related education, space-related experiences, which I think you're all doing today, and this week, which is just phenomenal. So again, a big thank you, a big congratulations. So let me just put in my 2 cents. I think you should all think about continuing to pursue experiences and education and training and even hopefully eventually career opportunities in space-related fields. Space is going to be, I think, such an emerging topic. It represents immense economic and career opportunities. Through space, we can more effectively tackle global challenges from climate change to inequalities. In fact, the World Meteorological Organization found that over 50% of the variables that we need to monitor to better fight climate change will be monitored through space. There are many reasons for someone to pursue a career in a space-related field. Again, space technology will increasingly help us monitor our land ecosystems and coastlines. It will support disaster relief and protect our oceans and forests. Through space, we're going to be able to address economic and social inequalities. It will help close the digital divide by providing high-speed connectivity in remote, rural, and indigenous communities. And there will be immense economic and job opportunities stemming from the new space economy. There are people that are projecting that the economy will grow to $2 trillion, the space economy to $2 trillion globally in the next decade or two, which will be able to support a lot of innovation, a lot of jobs, a lot of different industries, all the while hopefully tackling important challenges that worry us all. So really hope that you're all inspired with this week's event and talks. I really hope that you all think about staying involved in the space sector or space-related fields. I hope you all think about studying STEAM, which is great for an array of professions, but also very important for the space sector. And I hope you'll all stay in touch with Space Canada. If there's anything that we can ever do, you can be a part of Space Canada too. So please look us up online. You can send me an email, send us an email, and we'd be happy to be connected with you all. You can follow us on our social media channels, and hopefully we'll be able to find ways to collaborate in the future. So thank you, everyone. And if you have any questions or any comments, I would really appreciate to hear them. Merci, Walalim.
Okay, thank you so much. I really enjoyed that presentation or that talk. Really enjoyed hearing you talk about your contributions to your province and everything you've done. It's really fascinating stuff. If there's any questions, they'll just pop up in the comments right here. And yeah, we'll just wait and see for a little bit. Is there anything else that you would like to add? We have a little bit of time if you would like to say anything else.
Yeah, well, I think one thing that I would encourage everybody to do, you're probably getting a little bit of this with the amazing speakers that the organizers have lined up. Look into the space sector, look into what's happening. And if you haven't already done so, it's phenomenal. And no matter what you think is important, I'm quite convinced the space sector will be playing a role in helping advance something that you think is important. No matter what type of change you want to see in the world, I think the space-related fields will be playing a role. So I really encourage you all to educate yourselves and inform yourselves on what's happening. That's one of the things I enjoy the most. I'm learning so much. I'm educating myself, and I like to think becoming a bit more informed on some of the major trends, some of the challenges and opportunities that are in front of us as a country and as a globe. And all through space. So really just a word of encouragement to continue what you're doing here this week, to learn more about it, to experience more about it. And I think you're going to see that there's immense opportunities for you to do something that will be meaningful to your life.
Okay, that sounds great. Thank you so much for joining us today. Thank you for...
My pleasure. I really appreciate the invitation. I hope to hear from all of you soon. I hope you enjoy the rest of the conference.
Sorry. Yes, thank you so much. Sorry, we're just having a little bit of technical difficulties here at the site. no reception, no internet. You know how it is.
All good. All good.
Okay, I just like to take this opportunity before I end the stream. Oh, you can, yeah. Sorry, I'm not gonna take up any more of your time. Feel free to.
Great. Well, thank you, everyone. It's really great.
Thank you so much.
Bye-bye.
All right, for everyone else listening, thank you so much for joining us today. Thank you to all of our wonderful speakers and our sponsors and Launch Canada and all of the Stardust organizers. We'll be back here tomorrow with another amazing panel of speakers, including former CSA astronauts. So thank you all for joining us today. If you guys want to tune into the Launch Canada live stream, we're still hoping to get a few rockets up. All right, thank you. Have a great day. We will see you tomorrow.